Okay. Assalamualaikum warahmatullahi wabarakatuh. Okay. For today, we are going to proceed with the uh, next session. Okay. So the whole day will be conducted in this class, in this laboratory. Okay. So for this morning, we are going to proceed with the practical number 3, which is data analysis using enhanced Chemstation. But before that, we shall have a recap about what we have did in the evening of yesterday evening. Okay. So recap on identifying a compound. So we have yesterday distributed the installer and we have installed the enhanced Chemstation. And we also have provided with you with the GCMS dataset. And we have installed the GCMS enhanced Chemstation as well. Okay. Together with that, we have NIS 11 library. And then we have open one file number 100, which is the LUT. And we have identified the fatty acid. Okay. Uh, we also learned yesterday about how to zoom in and zoom out using this software, Enhanced Chemstation. We also learned about integrator, go to chromatogram, select integrator. Remember, we have Chemstation integrator if we want to compare the compound similarity against the NIST library. And we also have RT integrator, which will be used in the next session. What else? Then we need to integrate. So for an integration, the aim of having an integration is this software will identify the retention time, or we call it the elution time of individual compounds. Yeah. And then what else? We also learn about how to match against the library. So go to spectrum. You have to ensure that the library that we are going is NIST 11, but in this example, it is demo library. So you have to click to the browse, go to the database, and make sure you click NIST 11, and then click OK. And then we can match the library against the NIST 11 by clicking library search report. Usually, we will choose a screen over printer and then click OK. So it will produce a result. Yeah. Usually, if the picks are too many, they will create the result in the form of WordPad. Yeah. So this is a type of WordPad. So for us to easily see the complete list of compounds detected, you just make it into 8 font so that everybody can watch or can read the compound. Yeah. And then we also have here on how to see the similarity by looking at the last column. Yeah. For example, if we have, and we suggest to have 80 or 90% qualitative amount against the library to be considered as the compound is legit. Yeah. It's detected in the GCMS. Jumpa tak? Okay. So by looking at the last column, okay, so you can see here, for example, at 27.280 minute, we can get the cis-13 eicosanoic acid methyl ester with 99% similarity against the NIST library. Okay. Then, beside of that, we also can convert this result into Excel by clicking Export Report and then choose Library Search Results Report to XLS. So XLS means Excels lah. Okay. But I have to remind everyone, when you click or you want to convert them into XLS or Excels, when you click it, just let it be. Yeah. If we interrupt the transition, only limited numbers of result will be displayed. Okay. So usually it will take some time. So just when you start to click this one, you just let it be. Don't touch anything on the laptop. Okay. And then what we learn. Okay. So that is the recap that we have learned yesterday. If you want to try, we also can open the file number 15, which is we already did yesterday. File number 15 is the palm oil, where we can found the compounds lah. Okay. By the way, I would like to remind, what do you uh, anticipate actually from this result? The first window, there are two windows appearing here. Yeah, the first window is the scan mode. The bottom window is the sim mode. Remember yesterday we went to BTE engineering laboratory. Yeah, we talked to you. If we have standards, yeah, we have a pure compounds. In this case, we have fatty acid metaester compound. We have 37 compounds. So for us to ensure or to push the GCMS to only focus on this 37 compound, we need to use the SIM mode, selected ion monitoring mode. So when I did this analysis in 2016, I choose both mode. So the GCMS in the BTE, or sorry, in the UPM at that particular of time, we analyze scan mode together with SIM mode. That's why when we open a file, both of these windows are presented. So the top one is scan mode. You can see here data.ms. The bottom one is data.sim.ms. So the question is, what if we want to choose scan mode only? How? So you go to file at the left side, click select signals. So you can see there both boxes, data.ms and data.sim.ms are ticked. So if you want to look for data.ms, you just untick the data sim mode and then you can click OK. Okay. So you can see there only data sim mode will be appeared. So we can maximize the file. Yeah. Oh, nak tutup? Tutup. Oh, sini. Okay. So what if we want to see the sim mode only? So go back to the file. Again, click select signals. Untick the data.ms, but tick data sim.ms box. And then you can click OK. Okay. So you can see this is the data sim mode. Okay. So if we want to make a calibration curve, we will go to choose data sim mode. Okay. Okay. So people will be asking, so why we don't choose scan mode, or why we what is the beneficial of using scan mode only? Okay. So okay, the answer is, could we tick both of the data, sim mode and scan mode? Okay, so you can see what's the difference. You can see actually in the scan mode you have more peaks there compared to this scan mode. Compared to the sim mode, only 37 of compound or peaks will be detected lah in this one. Okay, kalau you tengok lah, you go to, okay, but you can see in the scan mode we also have additional compounds in the front. So yang depan ni apa sebenarnya? This is a solvent. Okay. And then there's also any impurities in the sample will be detected in scan mode. Scan mode will gather all information in the sample, anything, including impurities. For sim mode, only those compound, the mass of the compound that we have key in the GCMS will be detected. Yeah. So meaning that sim mode is more specific. Scan mode is scanning. It will scan everything lah. So if you want to know what are potential compound in the presence in the sample, we use the scan mode data. If we want to establish a calibration curve, we only use sim mode data. This is the lacking that in the laboratories services where they don't disclose to all of us. So you have to know which one is the best lah. Okay. Okay. Now we want to establish a calibration curve. Okay. So calibration curve can be established using the Enhanced Chemstation. We also can establish a calibration curve using manual approach using Microsoft Excel. So I will show both of these activities lah. Okay, but at the first place, let's setting up a calibration curve using Enhanced Chemstation. Okay, could you follow this arahan this command? Open up the GCMS data folder and then choose 15 file 15D. Open the file, load data file, choose this one 15D. So you can see here in the 15D, I have analyzed 37 fatty acid metal ester standard at the concentration of 50,000 ppm. Okay, and then you can click OK lah. Okay, for this one, you can choose any, no problem. Okay, so this is data sim mode only. Okay, for those who appearing both of sim and scan data, go to file, select signal, only choose data sim mode. Only choose data sim mode. Okay, data sim mode only. Because we want to establish a calibration curve. Okay, so you can see here, it is very clean 37 fatty acids standards appeared. Yeah? At this particular of time, when I analyze the sample, the GCMS ion source have been cleaned up first, and then the laboratory purchased HP88 column, very new column, so that's why you can see it's very clean separation lah. Okay, don't be jealous with that. Some laboratories, they are so rich at that particular of time compared today. Okay. But the good thing is I can give this data to all of you, and then you can see how a clean separation looks like lah. Yeah. So now, usually we need to establish 37 calibration curve for individual fatty acid. We have 37 fatty acid, but for the sake of this workshop, to shorten down the time, I prefer to show only three a calibration curve, meaning that only three compound will be selected lah. Okay, so which compound will be selected? Let me open my Mendeley first. All right. Okay, you can see here. Okay, actually, this result of fatty acid, we have 37 fatty acids. The published papers from my research, and this calibration curve actually was originated from these standards. Okay, so for that, I would like to establish for the sake of this workshop to have sekejap ya. Ini 10 10 10.2 10.3 10.21. Okay, so I would like to propose we establish three calibration curve for these three compounds: hexanoic acid, octanoic acid, and decanoic acid. Is it okay? Yeah, for the sake of this workshop lah. Okay, if not, we have to establish 37 calibration curve lah. You can do it on your own afterward, but I would suggest to have this one. Okay, so I will copy this one. I will put to the okay. No. Okay, so three compounds: hexanoic acid C60, octanoic acid C80 and also decanoic acid C100. Okay, done? Ready? Okay. Okay, now we have to click setup quantitation and key in information of the quantitation of database global. Okay, what we should click, go to go to calibrate, go to calibrate, set up quantitation, click setup quantitation. Okay, so it will appear a one window. So in this window, we need to key in the title of this calibration curve. So you have to say calibration, type calibration curve, free fatty acid, 3 frames. Okay, and then you can see, you can put your date lah. So I will put up like this one, calibration curve, 3 frame, fatty acid metal esters, 25 May 2022. Okay, done. And then on unit of concentration, for the rest, let it be. For unit of concentration, you type microgram per mil or ugram per mil. Microgram per mil. So if you don't find any micro there, just type UG per mil, which indicate ppm. Microgram per mil is ppm because this calibration curve is in the ppm unit lah. So for the ISTD main internal standard, unfortunately for this fatty acid metal ester standard, I didn't run any internal standard. So I just let it be as 0 lah. Yeah? If there is an internal standard, you have to put what is the concentration of your internal standard. Okay, so in this case, I don't use any internal standard, so I let it be as 0. Okay, cukup? Boleh? Cukup? Okay, so if it is okay, you need to click OK. Okay. So there is also a window, small window, will appear as edit compound where you need to register these 3 compound in this window. Okay. So how to register this compound? You need to click insert above. So do you see there is a small window appear? So this is where you need to register the compound's name lah. Okay. So the first compound name is hexanoic acid. Remember, hexanoic acid, but usually we don't put full name. We just use these numbers, P6 semicolon and 0. So you just type there C6 semicolon 0. So this is hexanoic acid lah. If you are more hardworking student or lecturers, you may type full name, hexanoic acid. Yeah, it's not wrong. C60. C6 double colon 0. C6 double colon 0. C6 titik bertindih kosong lah. Okay. It's up to you actually. Tapi usually for this hexanoic acid memang the nomenclature is in simplified form. They will put C6 double colon 0. If there is C entrance, lepas tu yang 0 tu akan berubah lah. Yeah. Okay, done? Done? Okay. Now, where is the compound? Okay, actually this compound you can see from the publication itself, Yani. The retention time of hexanoic acid is 10.144. It is this one, This one, 10.144 minutes. So you open your GC here, C mode, zoom. So this is the hexanoic acid. Okay, 10.11 time. Is it 10.1? 10.144 minutes, sorry. Okay, so zoom this one. Zoom. Okay. And then, kita pergi sini right click right click right click right click, this one. Okay, double right click. Is it there? Dapat tak? You get this one This one Okay. Tiba I confused pula. Okay, double right click and it will appear one window. This window named as mass spectral window. Meaning that if you click this one, this is the mass spectra of that hexanoic acid. Okay, so how do you want to confirm this mass spectra is the hexanoic acid? Okay, if you see at the publication again, the mass is of the mass of hexanoic acid is 130. So in that window, did you see 130? Correct, right? This one, yeah? So bring your cursor to this 130 until the top and bottom line of that square cursor change into white. Dapat tak? Dapat tak? Di atas line lah. Kejap ya. Okay, sorry Okay, okay. Then simultaneously click the what you call that one? Your tentacles, your mouse, both left and right. Yeah, yeah. That's why I'm asking. Bring more. So when you click simultaneously both and left and right mouse, it will inform you the mass in the system. It will register the mass in the system 130. Sekejap. Okay, for the second compound is C80. You have to again zoom. Okay, bring your cursor to the apex of this column. Right. And then double click to the right of your mouse. Is it? Okay, done. And then what is the mass of the octanoic acid? The mass is 158. So bring the cursor to the mass spectra mass of 158. Simultaneously double click left and right of your mouse. So you can see it has registered the mass 158 to the system. Okay, up to this part, have you reached? Yeah. Okay, if this is done, let's go to introduce or to register the third compound, the last compound. Click save again. Save again. So there is a small window asking for you to register the third compound. So you close first this max spectra window. What is the compound name? Decanoic acid, which is C10. So the compound number 3 as well, we need to register, which is C10. Do the similar work as we registered the first two compounds. Yeah. If it is okay, click save. Click save first and then click exit. Yes. So it will appear another we call a window stating that what are those compounds that have been registered lah. Alah, dah habis battery. Okay. Okay. So this is the 3 compound have been registered. Okay, the first one is C60. Retention time is 10.14. Signal mass is 130. So 130 is the compound's particular mass. Remember we do the C mode. So this signal mesh has been installed, registered in the GC, in the instrument lah. Okay. Then we also registered C80. Retention time is 10.930. Signal is 158. C100. Signal 186 with retention time of 12.293. So only 3. If you are so hardworking, you can proceed with the another 34 compounds. Okay. But in my case, I have 37 compounds. We will look later how all those 37 calibration curves have been established. Okay. So after that, you have to click exit. Okay. Just click exit. Tak apa. It's okay. So the file has previously been requantitated now. Just click yes. If it appear to you. Okay. Okay. Now it will appear a new window. Keluar this one, new window. Okay. Tadi 50,000. Oh, okay. It's okay, no problem. Okay. So now, if you remember, this file number 15, the concentration is 50,000 ppm. Okay. So you just type 50,000 ppm there. Okay. And then in this, you have to take note as well, we want to establish 1, 2, 3, 4, 5, 6 concentration. Yeah. So 15 is the highest concentration, this one. So it is 50,000. So what you shall do is, at this part, the level is level number 6, the highest one. Okay. So number 10 is level 1, level 2, level 3, level 4, level 5, level 6. I will inform you why we choose number 15 first. Yeah. Okay. So do this thing first. Level 6. Yeah. And then click do update. So the first 50 ppm calibration curve has been installed in this system, meaning that you can do the calibration within the GCMS enhanced software. We also will learn later on how to establish calibration curve using Microsoft Excel as well. But this one is within the software itself. Okay. So satu compound punya concentration 50 ppm dah masuk dalam sistem lah. Okay. So you can see here it is 50,000, and then this is first calibration curve for C60 hexanoic acid. Decanoic acid is this one, also 50,000. C10 is also 50,000 lah. Okay. Soalan dia, the question is why we choose the highest compound first. Usually we did calibration curve with the lowest one. Remember, this step is actually we want to register the compound in the system first. So usually if we choose the lowest compound, there's some possibility some of compound having a very low or minute signals. So it might not be registered or identified by the system lah. So that's why for registration of a compound, choose the highest compound first. Okay. Then afterward we will go to the lower compound. Okay, sampai sini okay? Proceed. Okay. So you just click OK. This is the highest compound, is level 6 lah. Yeah. If we go for the lowest compound, it start with level 1 lah. Yes. 6 concentration, so we put a level 6 lah. Okay. Current changes will be saved. Proceed, click OK. Okay, even though they said that current changes will be proceed, you want to proceed with save, yes, but don't trust the software. So go to method, click Save Method. You can see here, method is not saved. So please put back the name of method file, calibration curve, 3 frames, 25, 05, 20, 22. Which indicate what? In our life, we cannot simply trust everybody, even though the system, okay? Uh, so it's like double saving, eh? And then click OK. Make sure if even the system notify you, you want to save and proceed, you click OK, but you still need this to save the calibration curve lah. Okay. For this one, if it appear like this one, just click OK. Why it appear like the a new window there? Because previously this data have been used for previous calibration curve. Eh? Uh, because this is the I think second or third time I carry out the calibration curve workshop, so that's why it appear there. Okay, so you can see the method that you have saved is named there. Calibration curve 3 frame 2502 2022. So this is correct, lah. Okay. Now, now we need to register or set up calibration curve with the rest concentration, with the lower concentration lah. Okay. So what we need to do, go to file, open the lowest concentration, which is load data file, go to number 10D. Okay, before that, you can click 10 is 5,000 ppm. Data 11 is sorry. For example, you can look there. Okay, data 11 is 10,000 ppm. 12 is 15,000. 13 is 20,000. 14 is 25,000. The highest one is 50,000. Data number 18 is just a sample lah. Okay, so for registration of compound, we use the highest concentration. Now, we want to complete the calibration curve. We start with the lowest first. So go to data number 10D, which is 5,000 ppm. Click OK. This one just click OK. Done. Okay. So appear like this one. 10D. Go to file. Load data file. Choose 10D, which is 5,000 ppm. Click OK. Okay, what you should do now? Go to chromatogram. We have to integrate first. We just open file. We want the system to integrate first. They need to identify which are retention time for each compound. Go to chromatogram, select integrator. So choose RTE integrator because we are establishing calibration curve. Remember, having a Chemstation integrator, if we want to compare the library, the NIST library. This one, we don't want to compare with the library because we have a very pure compounds as standards. So we go for RTE integrator. RTE means retention time integrator. So the system will compare the retention time of the introduced three fatty acid against the retention time of the new lowest concentration. Okay. So if it's open there, click OK. And go to chromatogram, click integrate. Okay. Done. Then go to calibrate, click update. So, and then it will appear one window. Dia tanya, they ask update one level, click OK. And if there is appearing of a new window said file has been previously quantitated, requantitated now, just click yes. So this one is 5000 ppm. So type 5000 ppm. Okay, 5000 ppm. Remember, this is the lowest concentration, so it shall be 1. Level 1. And then click do update. So you can see there are 2 points have been registered to the system. Okay, people will be asking, so this is, if this is calibration curve, how to see the R square? You go to this calibration tab, you can see the R square is this one. Coefficient of definition R square is 1. For compound C60, C8 also 1, C10 also 1. But don't so happy yet because only 2 concentration. We have another 4, 2, 3, 4, 5. Another 4 concentration to be registered to the system. Okay. So for now, click OK. Current changes will be saved. Proceed. OK. So what we shall do now? Don't trust. Go to method. Save method. And then click OK. Yeah, save both twice. Jangan mudah percaya dengan orang lain. But you can trust me, insyaAllah. Okay. So now, open another second concentration, the higher one. Go to load file. Go to file number 11, which is 10,000 ppm, and then click OK. Okay, just click OK. Just click OK. So this is what we shall do. Go for chromatogram. Select integrator. You have to make sure the integrator is RTE, and then click OK. Go to chromatogram, integrate. Done. Up to this level, we want to update the calibration curve. Go to calibrate, click update. And then they will be asking update one level. Definitely you have to click OK. Yeah, file has been previously been quantitated, requantitated now. Just click OK or yes. Okay. So this one is how much the concentration? 10,000, correct? 10,000. Level is level number 2. Okay, and then is it 10,000? Okay, betul. And then click do update. So there are 3 standards have been registered to the system lah. So you can see the calibration curve. See, it is being reducing. Yeah, 0.9999, 99976, and 99976 lah. Okay. So if it is okay, try to do on your own. We proceed with the next higher concentration. Click OK aja. Click OK first. Don't forget to save method. Yes. Okay. Okay, now go for the higher concentration, which is file number 12. You have to remember this is 15,000 ppm. So go to OK. Okay. And you have to make sure this file is being appearing first. File number 12, 15, which is 15,000. Go to chromatogram. Select integrator, RT integrator. Okay. Chromatogram integrate. And then calibrate, update. Update one level, click OK. Yes. 15,000. And then the level is level number 3. And then click do update. So you can see the calibration has been updated. Okay. And then click OK. Method, save method. Okay. Now move to the higher concentration, which is number 13, which is 20,000 ppm. Do the similar approach. Chromatogram, integrator, chromatogram, integrate, update, yes, 20,000 for Do update. Okay, okay, okay. Save. Then go to the last concentration, which is 25,000 ppm. Okay, okay. Chromatogram, select integrator, RTE integrator, chromatogram integrate, calibrate, go for update, update one level, yes, 25,000, level is number 5, do update. Okay, okay, method save. Okay, I will wait for everyone to complete up to this. We have six concentration. Done. So you can see the calibration curve, R square has been reducing. C6 become 0.994, C80 0.99, and then C10 is 0.994 lah. So usually for fatty acids, calibration curve, it is recommended to have at least 299 after the decimal point lah, the lowest one. The higher the value is better lah. So R square equal to 1 is the ideal one. Yeah, the best. Okay, have we complete up to this part? Okay, so this is a calibration curve, but you have to take note, the calibration here only cover 6 points. But for those who dealing with method validation and verification, calibration curve shall contain at least 7 points including blank. So in the case that we run the GCMS, try to run blank, one simple blank, make it blank as the another level. So usually blank will get 0 point, so it will plot another 0 here lah. So you will get 6 point. So 7 point of calibration curve including blank. So meaning that one blank, another 6 concentration. So if you are advising student in the lab, in your master or PhD student, that is the recommendation. Most people only use 5 calibration point, which is inaccurate. Yeah. Usually in my Department of Chemistry Malaysia, in my tenureship, the way that we evaluate the what we call that one, expertise of any chemist, those who can get R square nearer to 1 will be applause. How they compare between registered chemists, So usually, I managed to achieve 0.9999 at one particular of time lah. Tapi it's very hard lah, yeah. But this is enough actually. You have 29 after the decimal point is acceptable actually, yeah. But most of publication they get 0.98. But if you get 0.99 is better lah, yeah. So if you are hardworking, you can prove to proceed with the 34 fatty acids, the rest. Yeah, but at least you can do it the same lah. Okay. So this is the calibration curve using a Chemstation. Okay. So the question is, if you have saved this one, you want to open back the calibration curve, go to calibrate, click edit compounds. So the calibration curve will appear again. Okay. So what next? Enhance. Okay. So this is okay, before that, this is a calibration curve. So if we want to identify or quantify how much fatty acid, these 3 fatty acid in our samples, macam mana? How to quantify? Okay. So for now, open one file, click a file, load data file. Okay, how about if we choose palm oil, which is the number file is 18, 18.d, palm oil, click OK. Click OK. Okay, so it will appear both of this scan and sim data, but our calibration curve in sim data. So go to file, only choose, select the signal, choose sim data only. So this is the palm oil sim data. Okay, so do the similar approach. Go to chromatogram, select integrator, make sure it is RTE, click OK, go to chromatogram and integrate. Go to chromatogram, before open the file, load data file, choose the 18.d, which is for palm oil. Okay, click OK, click OK, and then you have to make sure you only choose signal which is sim data. Click OK, and then proceed with a similar approach for the standards. So go for chromatogram, select integrator, choose RT integrator, click OK, chromatogram again and integrate. Okay, so after you do this integration, now to quantify, go to quantitate, click calculate at the top one. Go to quantify, click calculate. So the result will be appear this one. So C60 in your palm oil, in your palm oil containing 494 ppm of C60. So you don't have to manually calculate using this software. Boleh percaya. It is based on the calibration. Yeah, the one. So now, is it easier for us to copy and paste here into this data, into our thesis? No, no. You can export to Excel as well. So go to export report, click export report, click quantitation results report to XLS. And let it be. Don't touch it after that. So let the Microsoft Excel to operate. Let it be first. Biar dulu. So until you can see there. So when they reach this one, DDE channel terminated, that indicate the Microsoft Excel has completed on the operation. So you can see this is the Excel's results lah. So you just copy this one, put in your thesis. Kita tambahin lah cara kampung-kampung ni no. We go to higher level. Okay. Okay. So that is why I propose to have this kind of workshop. Everybody shall know how to do this one. We have this kind of advanced software, but we still need to do the makcik-makcik one. No, that's not us. Okay? Okay, but sometimes people will be asking, yeah, quantitation. Quantitation results. Quantitation meaning that we want to calculate. We are computing. Okay? So this for palm oil. Okay, if you want to try, Q value is like the match. Yeah, definitely you are matching the against this your standard, against your fatty acid standard lah. So definitely 100. You are matching there. Okay, it's like your qual value in your scan data, scan result. So you don't have to calculate now. Okay, so how about we try to go for the large sample? Okay, for this one, you can save first, or if you don't want to save, you have to close lah. The Excel cannot be operating. They cannot create another Excel if you don't save and close the Excel. Okay. Okay, so this one I want to close as well. Okay. So how about we try to identify how much fatty acid, these three fatty acid in the large sample. Okay, go to file, load data file, which is, where is the large sample? Data number 100. Large. and then click OK. Okay, so please do the similar work. Ensure the file that you choose is C mode only, and then go to chromatogram, select integrator, make sure it is RTE integrator, go to chromatogram as well, go to integrate. Then after the integration, go to quantitate and then click calculate. So you can see the result, it is lat3. So this is the result. You can see we still have the similar compound with their particular concentration. Yeah. And then try to export into Excel. Go to export report, choose quantitation results report to XLS, and then let it be first. Don't touch anything. Let the Microsoft Excel operating. Okay, so you can touch the software when you found this at the bottom. DDE channel terminated that indicate the Excel have completed their operation. So this is the result. Yeah. Okay. For the equation of the calibration curve, again, go to your Enhanced Chemstation. Go to calibrate, click edit compound. At this part of a window, go to calibration. This is the we call that one equation. Yeah. So constant term is your C intercept. Yeah. Linear term is your slope. Yeah. So 9.3 exponent negative 2 is your slope. Your constant term is C, which is intercept, this one. Yeah. Negative 4 exponent 1 lah. R square is 0.994. Okay. So again, we have, at least I have spread the advanced level of Malaysia's graduate and also lecturers. We have to move higher than others. Okay. So yeah. Uh-uh. Letak je blank dia. Even you want to put level S7 is okay as well, no problem. Because the blank will become 0, so the calibration still appear. Yes. Letak 0 je lah. If you can run a blank and then introduce, do update as a 0 concentration. Yeah. So make sure you are telling your student with the correct approach. Okay, done this part. Okay, this is we have make sure go back to method, save method. Click OK. Even though we don't touch anything, just save, no problem. Because in my life I have a lot of trust issue, so including the software lah. Okay, so now to make it a little bit wow, try to go to method, load method. Okay, it will asking again, be sure changes are saved, load now, yes, click yes. Okay, now could you go to your the data that I share to you, the folder yang data for this training. Yeah, wait in my data set for our training, our workshop. This one teaching. This one. Biomarkers, document file for GCMS workshop. Okay, go to FAME Scan SIM calibration curve 0706-2017. Go to this one, click OK. Yeah, just click OK there. Done. So you can see here the top at the top, 3 FAME. It's still there. But it's okay. Try to click calibrate and then click edit compounds. So I have prepared for you 37 fatty acids there. Yeah. This one starting from 4 ppm until 2000 ppm. This is the one that I want to share to you. Okay, so you can see on calibration curve, the R square. You can click. But unfortunately, this calibration curve cannot be used for your research lah because different instrument. Yeah, retention time is different even though the mass is the same lah. Yeah. Okay, so this is the how the 37 fatty acid looks like lah. Eh? For this one, we have how many level? 1, 2, 3, 4, 5, 6, 7, 8. Already enough for method validation. Okay, so this is how a full calibration curve for fatty acid metaester. Okay, so this is the publication is from here. This one you can simply download because I don't submit for Q1, Q2. I just go for open access, which is I get invitation from this journal, Food Chemistry Advances, but they don't have any index. So that's why I just simply publish so everybody can follow the calibration lah. Okay. So this is the mass that people are being asking lah. This one your acid is the mass. How? Yang ni boleh cari, boleh Google je yang ni. Ya. Dan okay, another thing, if you open the invitation in our Google yesterday, sekejap ya, this one good. I have provided the YouTube recording yesterday. So open through here and then you can click to watch the video lah. Together with that, I have provided the timestamp as well. I just pause this one sebab malu dengar suara sendiri. So this is the timestamp. If you want to go simply to the specific part, you just click here. So you don't have to go one by one watching or listening me nagging about this GC talk yesterday. I should just go to click here. Okay. And please subscribe. Okay. Okay, I think that's all for just to inform everybody. Okay, so this one is okay. Addressability is my class lah. Problem. Okay, what else? This is Google Classroom. Okay. Kita tengok balik what you shall have here. Okay, this one we've done. We opened the 37 theme. You can also watch the YouTube reference for this one. I have also prepared a YouTube specifically for developing this enhanced Chemstation calibration curve. But this current workshop as well, I have also recording. I have this recording lah. I will provide the recording as well. Okay. Okay. So this is how it looks like the calibration curve. Just an example lah. Now we will move to another calibration curve using Microsoft Excel. How? We will come back at 11 a.m. Okay, now we want to proceed with another way of calibration curve, especially if the student or when we send a sample to lab, we don't have the software. Kan? So we don't have the software, and even if the technician doesn't know how to use the software, what we can request from them lah. Okay. Udah. Now, you can try to what if we want to so because of this lacking of the software, we can also make a calibration curve using Microsoft Excel. So how to do it? So we start with the lowest concentration first. Go to file, load data file. Okay, choose number 10 D and then click OK. Click yes. Click yes. Okay, so it will open the first concentration, the lowest one. So what we can do now, we can go for click chromatogram, select integrator, make sure you choose RTE integrator. Okay. And then go to chromatogram, click integrate. So make sure the compound that we are looking for a calibration curve already integrated. So dalam case ni, In this case, we want this 3 kan, patutnya. So, yang ni, I think this, we want this 1, 2, 3. So, if it is not integrated, you can go to chromatogram, select MS integration parameter. Sekejap ya. Sekejap. Very low. Okay, never mind. If we want to make a calibration curve using this one, kita pilih select integrator, MS integration parameters. We can reduce actually this one, baseline allocation, starting. Sekejap ya. Okay. No, okay. Integrate. Oh, tak boleh juga. As integration parameter, can we go to lowest minimum peak area? Yeah. Let me try first this one. Okay. Okay. So if you refer previously, when we click chromatogram and integrate, the compound that we want, C6, C8 and 10 are these three. Kita nak ni these three compound. But only 2 are integrated. This one not yet previously. So if you found that one of the peak is not integrated, you can go to chromatogram, click MS signal integration parameters, reduce this minimum peak area to 1. We want to make it more sensitive so that any compound is not integrated being integrated lah. This one threshold ni actually if 0.5 is okay, but actually if we change this minimum peak area to 1, it will become sensitive and can integrate the compound which is not integrated at the first place lah. Yang ni kalau nak maintain 0.1 pun boleh, 0.5 pun okay. Okay? Boleh? So usually if we reduce this to 1 or lower, those very small peak will be detected, will be integrated by the software lah. Yeah? Okay, up to that part, is it okay? Boleh? Boleh? So do you find this thing? Boleh? Tiga-tiga, these three peaks already integrated? Correct? Ada issue? No? If there is no issue, I will proceed. Okay. Now, we want to make a calibration curve for the hexanoic acid C60. I just show one peak sajalah. Okay. So, this concentration of 10D is 5000 ppm. Correct? So, open your Excel. Kita buka satu Excel file. New. Yang ni kita tak nak tadi So, this one shall be concentration. You want to do it manually This one is area. Okay. The first concentration is 5,000 ppm. So from this result, this is for C6. Concentration C60 concentration The unit is ppm. We want to make calibration curve using Excel. So since the first compound here has been integrated 0.126, we want to find the area of this peak. Macam ni nak find this area. After you make sure it's already integrated, go to chromatogram, click integrations results. So it will appear a new window with all peaks that being detected, integrated peak, the retention time, and then the area is here. So the compound of C60 at 10.12 retention time, the area is here, 1427. Oh, sorry. 1427. So kita boleh buka dekat sini 1427 lah. Copy paste pun boleh. Ya. Okey, boleh sampai situ? Dan okay, now we want to find the area for the higher concentration. So go to file, open file number 11, click OK. Make sure you are using the C mode, click OK. Go to chromatogram, select integrator, shall be RTE integrator, OK. Chromatogram and then integrate. So you have to make sure the peak that the one is 10.112 ni integrated lah. This is for hexanoic acid C6. Okay. So afterward, go to chromatogram, click integrations result. So your hexanoic acid 112 at 10,000 ppm is the area is 3034. So you can copy that one 3034. This is 10,000 ppm. Okay. Then close. You can open another file with the higher concentration. This time is 15,000 ppm. Carry out the similar approach. The grade, so this is here, 10.126. Go to chromatogram, click integration results. 10.126, the area is 4817. 4817, 15,000 ppm. This one for manual in the case that if the lab assistant doesn't know. Go to again higher concentration at 20,000 ppm. Integrate integrations result. 10.126 is C2 6250. 6250. This is 20,000 ppm. All right. Then close. Load data file. Go to number 14. Okay, carry out the similar work. Integrate. Okay. And then chromatogram integration results. 10.140, 8950 area. 8950. So this one is 25,000. And the last but not least, 50,000 ppm. Again, integrate chromatogram integrations result. 10.140 is 16136. 16136. Is it correct? 16136. 50,000 ppm. Okay, sampai sini okay? This is only C60 lah. Dia jadi penat sikit because we have to do it manually individual compounds lah. Okay, so to set up a calibration curve, just highlight this one, go to insert, click scatter plot. Banyak 60,000. Mungkin itu ambil scan mode kot. Make sure it should be C mode. Okay. So this is actually your C60 calibration curve. Okay. So yeah. Highlight this one and then click insert, click here scatter plot. So you dapatlah calibration the plot lah. Okay. So I make a proper label on the title C60 calibration curve. You can click here and then go to chart design kat atas ni, at the add chart element. Okay, go to axis titles, this one. Okay, so letaklah kat sini, this is the concentration. Unit is U gram per mil, which is ppm. Do the similar activity, go to add chart element, go to axis titles, primary verticals, go to area, type area here. Okay, so this is your calibration curve. Now we want to proceed with producing the linearity curve and the R square. So similar, go to chart design, click add chart element. Okay, and then go to trend line, click more trend line options, click at the bottom one here, display equation on chart. So you will see the calibration curve is, the linearity is y equal to 0.328, x minus 0.2.39, R square is 0.9941. So this is the equation lah. Okay, so up to that, this is the manual calibration curve without using the enhanced Chemstation. We just do it manually lah, but it is C60 compound only. So if you have 3, you have to do it manually that way. So that's why I prefer everybody to use the software. It will be easier. Yeah. Tapi kalau rajin, no problem. I know. Okay. Okay. So you also can watch the YouTube here. I have prepared for how to create this one. Okay. Okay. So this is for calibration curve. Okay, so from this calibration curve, try to extract out the information. Yeah, the formula is y equal to 0.3298x minus 102.39. Okay, with similar work. So your slope is 0.329x. Your intercept, which is C, is actually negative 102.39. So you paste here. Okay. And then you have to put, can you put here sample? concentration. Okay. Now we want to do manual calculation for the C60 in palm oil. So similar work. Go back to Chemstation, Enhanced Chemstation. Go to File, Load Data File. Click the 18D sample, which is palm oil. Click OK. Make sure you are using the cyclic signal data sim. Integrate, and then from here try to, no, you have to zoom actually. It's not integrated or it's not there. Tak ada kan? So kalau tak ada tu tak ada lah. Okay, for example lah, we put an example. For example, it is there in the palm oil and it's also integrated. So we want to find the area or in the palm oil of C60. Click integration result. Okay, how about we just assume this one 169144 is the area. Contoh lah, this is C60. So you copy this information. Your sample area is berapa tadi? 169144. 169144. Sorry. Yeah. Sample area. Silap. Sepatut kat sini. Okay, so sample concentration is sample area is 169144. Sample concentration is you need to add this information to this formula so that we can calculate the X lah. Okay, so sample concentration will become equal to sample area macam mana tu? Kita nak tahu concentration kan? Y area, okay. Tambah at 0.2.39 divide by the slope. Betul tak? So this is the concentration of C60 in your sample. We just assume lah macam ni nak to get the area lah. So this is the calculation lah. Okay. So for the X, the formula will be Y minus negative 102.39 divide by the slope, which is 0.3298. So you will get the concentration is X lah. So this is the actual, when we want to calculate the X, so this is how we do it lah. So you can get the result. Yeah. Okay. Okay, to get the sample concentration is the X. So X equal to Y minus the intercept divided by the slope. So if you are using this formula, you will get this concentration lah. So yang ni formula dia lah. Ke air terbalik letak kat situ? Kurungan ni This one Kalau tu dia tambah lah kan. Is it this one? Betul. It should be this one lah macam ni kan. Okay. So you will get the concentration of this one lah. So unit dia ialah, the unit is gram per mil. Okay. So this is how manual calibration is being set up lah. And to calculate the samples, we use this formula. Okay. But again, for those yang very hardworking lah. Kalau tak berapa rajin, kita pakai the calibration curve. We will prefer to use this one. Okay. Okay. Up to that part, is it okay everyone? Okay, this is how it looks like. So this is from the YouTube. Okay. So this part, we are going to move into the second session about this workshop, which is principle of chemometrics for halal authentication. So we know everybody nowadays, as I told you yesterday, those very oldest researchers, they really look into ANOVA, t-test, f-test. They are the common statistical analysis. But nowadays, people are moving into chemometrics. Sometimes we call it environmetrics lah, chemometrics lah. That depend on applications of our studies. When we say about chemometrics, it's like chemicals in different metrics, multi-variables. If we say that environmetrics, which is in the field of environmental study using multi-variable, multi-metrics. If people say econometrics, they are study multi-variables in economy. So when we say about chemometrics, it's just a jargon that play around lah. So actually chemometrics is chemicals being used as a variables in different matrices, and then in general we call it multivariate data analysis. Okay. Okay. So on this section, before we move, actually we are going to use this software, XLStat software. So I recommend you go to this XLStat website. You can go to the note that we have shared to you, the PDF one. You can click, it will bring you to the website of this XLStat. Okay. So if you go to this XLStat, please click try now and then install. Try to click XLStat, and then if it appear this part, click try XLStat. Okay. Choose your operating computer operation, whether it's Windows or Mac. Okay. And then choose installer, follow the direction or command post the installation lah. Okay. And some, as far as I know, they might request you to register for the installation. So if you have successfully installed this SLStat, this is a 14 days trial. SLStat, you can open the Excel like this one. There is a tab here at the top, XLStat. So you can click this one, click this XLStat, and then it will produce a set of data analysis in the XLStat lah. Okay, but mine is 2019 version. So yours is 2022 or 2021 version, which is more advanced than mine, but it's almost similar approach that we are going to use this evening. Okay. So actually this is 14 days trial for this workshop. Okay. So let's go about the topic of chemometrics, which is the second part of our workshop. So chemometrics is the chemical discipline that uses mathematical, statistical, or other methods employing formal logic or to design or select optimal measurement procedures and experiment, and to provide a maximum relevant chemical information by analyzing chemical data. So that's why if we have chemical data, that's why we call it chemometrics. If we have environmental data, sometimes people will use the jargon of envirometrics. So you can, if you want to read more about this chemometric, you can directly click the link. This is in our PDF file as well. Chemometrics use multivariate data analysis, usually having a variable number more 3 and above for this purpose. For a revision, data types can be divided into number of variables. If you are using one variable, we call it univariate data. If you have two variables, we call it bivariate. If it is 3 and above, we call it multivariate data analysis. Multivariate variable lah. So let's see, let's have some revision. Okay, so we learned about univariate in our statistical class in our undergrads. In our undergraduate. So when you have one variable for one sample, okay, you can see this in an example, sample 1, sample 2, sample 3. This is amino acid sample. B stand for bovine. We also have another amino acid in fish sample. F stand for fish. We also have amino acid sample. P stand for pork or porcine. Okay, so the only variable that we measure here is HYP amino acid, which is we call it hydroxyproline. So one variable, one variable, one variable. So when we have one sample for one variable, we can display the results using this frequency distribution table. We also can display the result in the form of pie chart, even a bar chart. Okay. Other tests that we can conduct univariate data analysis for t-test, ANOVA, Mann-Whitney test, Wilcoxon rank test. This will not be covered in this workshop because we covered the high variation data, which is multivariate. This is just for a revision lah. Okay, so if we have more than one variable, for example, two variables, we call it bivariate data. So if you have two variables, what test that we can carry out? We can carry out Z test or T test, to measure differences of mean between two groups. We can calculate Z test or Z test. To check the presence of relationship between two variables, we can use chi-square test. We also can have our calibration curve. This just now we use this scatter plot or regression analysis to find correlation coefficient. So you can see the R square, so on and so forth. So having a calibration curve for our fatty acid is we consider bivariate data, area versus concentration. Okay, so this is just a revision of what are the common tests that people do when they have one variable. One variable, when we have one variable and two variables. Okay, so if we have more than that, we call it multivariate data. Okay, so this is an example. We have amino acid, and then we have 17, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 amino acids here. Okay, I'm sorry about this one. The hydroxyl proline is colored with a black. Actually, nothing wrong with that. I just don't change the color into green, okay, into yellow. So, nothing problem with that data actually. So we just want to tell you when we have 13 amino acid, this one, if we carry out any analysis, statistical analysis, we call it multivariate data analysis. 3 and above variable, we call it multivariate. Okay. So when you have multiple variables for one sample and we want to know the relationship among the variables, we call it multivariate data analysis lah. Okay. Okay. And again, why we use chemometrics for multivariate data analysis? When you have 3 and more variables, and we want to know the relationship among the variables. Okay. What we can do with multivariate data analysis, we can identify the sample grouping. For halal authentication, we can identify using the fatty acid that we did just now, whether they are coming from porcine, bovine, or even fish. We also can identify the amino acids composition between these three groups, and using this multivariate data analysis, they can assist us on the sourcing information. From this multivariate data analysis as well, we can identify significant variable contributing to each sample. For example, I have fish, I have bovine, I have porcine samples. But which fatty acid are dominant in individual sample source? We can also identify these significant variables or significant fatty acid meta-ester in this individual group. We can also predict an unknown sample. What we can do this one, we analyze those fish, bovine and fish and porcine, make it as a database, and then if one person coming to your lab sending an unknown sample, they want to know whether those oils, those sample belong to which source, we can run multivariate data analysis to confirm the sources on unknown sample. Okay. So usually for now, previously in food analysis, data are becoming from increasing from univariate become bivariate. Now we are moving to multivariate data analysis. And even in one sample, we can get more variables in terms of metabolites. Okay. So using this multivariate data analysis, we can learn more insights in our samples. Okay. So this is just an introduction. So the one that I'm going to do for hands-on this evening, belum lagi baru pukul 12 lebih, this evening is principal component analysis and discriminant analysis. But from my experience, when I review papers, when people say about multivariate data analysis, especially in food, they fail to address this issue. They don't treat evaluation data, missing data. They don't identify or remove any outliers. They don't tell us whether the data is enough or eligible for chemometrics or multivariate data analysis. And they don't make sure the data is following the normal distributions. So that's why I bring this part. Everybody shall follow this flow lah. Okay. Kenapa kita cakap this flow? Because when we want to make a halal authentication as a method, you have to make sure everybody follow the similar approach. Removal of outlier. You make sure your data is enough for multivariate data analysis. We are going to use Kaiser, Mayer, or Kin test. They will indicate whether your data set are eligible for multivariate data analysis or not. If it is not adequate, you need to collect more sample. Data transformation, you have to make sure the data follow the normal distribution, so on and so forth lah. Okay, so this is the prerequisite of multivariate data analysis or chemometrics that you need to carry out before you move to principal component analysis, before you move to discriminant analysis. Okay, banyak case, publish paper, but they don't fulfill this requirement. That's why when we try to repeat, we cannot produce a reproducible results. Okay, so let's go one by one on evaluation of missing data. Okay, missing data occurs due to undetected variable or any detected variable that having a below limit of detection. This occur if you are dealing with method validation and verification works. For example, we want to develop a new detection method. Okay, so we need to carry out or follow through the step of method validation and verification. So it's compulsory to carry out a limit of detection step. Yeah? But most of the time when we carry out this analysis, the value that we receive or we quantitate using the calibration curve below the LOD, below the limit of detection, actually we need to treat this data that which is below than LOD, which is unit 2 times 0.65 of the LOD. This is an example. Sorry, very small here. We have this amino acid, hydroxyproline sampai methionine, so on and so forth lah. So each of these compound, they have their limit of detection. Okay, but if you run your samples and your concentration that you calculate is below than the detection limit, so you need to replace the below detection limit by times the 0.65 with this LOD lah in your data, in your Excel lah. So other options of evaluating and treating missing data, you can also remove the observation, estimate missing data by computing the mean, and etc. Some statistical software provide algorithm to ignore the missing data lah. Okay, so this is how we evaluate missing data. Okay, the good thing is about Excel stat that we have here. Yeah, I give an example. If I want to carry out principal component analysis with 3 and more variables, they have part which is data option. If you have missing data, they provide the proposed solution. You can don't accept data. They can propose to remove your observation, estimate the missing data for you. Yeah, so this is the automated that have been built in the system. Yeah, but even though we have this kind of facilities, I will recommend you treat your missing data within your Excel on your own first. Yeah, so that you know or you really understand about your data before we carry out any chemometrics analysis. Okay, so yang ni lah yang ada dalam, this is what we have in the Excel stat. I'm not so sure about other software. We have Simca, we have MATLAB, we have Unscrambler, we have JMP, which is the price of this software is 20,000 ringgit and above. Some of universities such as they subscribe JMP. Okay, but in this workshop, I just use Excel stat because we can simply open your file in your Excel and then you just do it on Excel. We don't have to import or export your data to the other softwares lah. But I'm not relating kita panggil apa, memburukkan other software lah. Yeah, other software they also have advantages and some disadvantages. But when I use this Excel stat, because I know what happened behind of the Excel stat, so that's why I propose to use this one in this workshop. And at least if it appears any result, I can explain to all of you lah. With other software, I'm not familiar, so perhaps I don't properly explain to you if there is wrong answers. So that's why I prefer to use this kind of software lah. Yeah. Apa lagi? Okay. Then we move to the next prerequisite requirement. After we treat the missing data, we have to identify and remove outliers if needed. Okay. Outlier is defined as a variable value that exhibits an extreme value from the majority's value, meaning that we carry out a repetition of analysis, then we get the mean value, yeah? And then from those individual results, if it falls beyond the mean value, it can be considered as the outlier lah, yeah? But usually we can count as outlier as 2 SD, 3 SD, yeah? It's become an outlier. Okay. If no sample grouping has been identified, okay, we can perform box and whisker plot, Grubbs or Dixon test at alpha of 0.01. This is not A, alpha. Because I'm using the word of font of century Gothic, so the alpha become A. Okay, alpha 0.01. So we will use this approach in this workshop. Okay, so in this Excel, if you want to do it, the outliers identification, yeah, we can use in this kita panggil apa tadi ya? This one, univariate plot. From here we can get the results of box and whisker plot lah. Okay, so this is an example. Decision of outlier removal is case by case basis. For halal authentication, usually we do this approach. We choose different sources of samples. We make a replication. Yeah. So for example, I choose fish gelatin, bovine gelatin, and porcine gelatin. So each gelatin I analyze 40 times, for example. Yeah. So from there, I make a box and whisker plot, and from there as well, we can identify the outliers. Okay, kat mana tengok outliers? You can see here there is a small dot there. So for this individual amino acid, there is at least one outlier for each variables. In this case, histidine doesn't contain any outliers. Yeah. So this is we can remove this outlier first before we carry out principal compound analysis afterward. Okay, so we can also carry out outlier analysis using bovine gelatin and porcine gelatin. So this is how a box whiskers plot will provide a results lah. Okay. Since removing outliers is case by case basis, and we talk about halal authentication, so the example that we need to follow is this, yang ni. We follow this one for halal authentication. But in the case of you are doing other work which is not halal authentication, and the repetition of your sample is not that much. Kadang-kadang kita repeat 3 times only. So usually, we can make this outliers identification as well. But there are too many outliers. If you have 3 replications, and then 1 or 2 of it are the outliers, so the other approach is you don't remove the outlier at all, or you remove the outlier and make another repetition until it's all fall into a no outliers being detected. So this approach by approach lah. You may choose to not to remove if your repetition is very low. Your number of samples is very low. It's very hard to get samples. There is one student, they carry out analysis of metabolite samples taking from Antarctica. So do you think is it easier to have a replication? No, right? So in this case, if they found outlier, they have to state they don't remove outlier. They take it as it is. Right? This is in the case of not for halal authentication, so you don't have to remove lah outlier. But if you are carry out a halal authentication study, do more replication, carry out outliers identification and remove them is my recommendation lah. Yeah. This has happened in a few papers. Okay, this paper ni contoh lah paper ni. This the paper that we carry out for amino acid analysis in gelatin. We carry out the similar approach. We remove the outlier. Another paper, sekejap mencari. Okay, this one as well. This is also a paper by Jakim Laboratory. So we carry out halal authentication and then we identify outlier, we remove them before carry out multivariate data analysis. Okay? So this is my recommendation for those dealing with halal authentication because our workshop is talking about halal authentication. So if you are coming to this workshop looking for halal authentication, this is the approach lah. Okay. So if you are not dealing with non-halal authentication, you can just simply accept the outliers in your sample, especially your sample is not enough for repetition. Okay, so that is my recommendation lah. Okay, yeah. Halal authentication, my recommendation, repeat more than 30. For this paper, this one, the Dr. Azilawati yang ni, she's the one who prepared the analysis. She repeat 40 and above. Yeah, because she want to halal authentication, we need to build a database. So for us to build a proper database, higher repetition will be giving a more precise database lah. Yeah, porcine, fish, bovine. So lagi banyak database, you can remove more outliers, and then you will have a very precise database. So this one for halal authentication, my suggestion. This paper, I tolong tulis je. Dr. Azilawati ni yang sangat rajin, prepare, but unfortunately she didn't stay in Jakim anymore. She moved to KKM back. Ya, dia dikaderkan. So she request me, could you write the publication? She already collect all those data lah. So she just gave the data for me. But it's very lengthy process and very big data that I have. Yeah. No, sometimes perhaps 3 fish, but more repetition. Same samples. And sometimes there are some fish yang macam catfish. Ada some fish with their scales dengan sisik. Dia kan different group kan. So this fish with scale dia akan repeat 40 kali. This fish macam catfish ikan haruan ke apa so on so forth, dia akan repeat 40 times as well. Dia pun buat macam tu. Same parameters, same HPLC, same calibration. Calibration curve is still the same. Sample to repeat banyak kali. Memang banyak. This one yang memang paling rajin yang pernah jumpa. I just tolong tuliskan paper je. Okay. 3 kali pun dah penat kan. Okay. So for this another prerequisite requirement, prerequisite for multivariate, kita ada sebut tadi kan yang ni. We talk about this one. Evaluation of missing data done. Identification and removal of outliers with box plot done. Now we want to collect or perform assumption testing multivariate data analysis. Okay. So apa yang kita boleh buat, what we can do, we want to make sure whether the data that we collected are enough or not. Kadang-kadang some people just run 10 times and then they just publish. But is it enough? And how we want to say enough? Remember when we learn about statistics in our undergrad, they say that number of samples is considered representative of a population is 30. Remember? Data kena 30 baru boleh carry out statistical analysis. Itu kita belajar dulu. But that one for one univariate. So if you have 3 and more variables for multivariate, can we follow the number of n equal to 30? Tak ada lagi orang sebut. Until there is one paper, it's not one paper lah, most of environmental study who carry out multivariate data analysis or chemometrics, they use this test. We call it Kaiser-Meyer-Olkin test. So from this Kaiser-Meyer-Olkin test, they choose the significant level as at 0.01 or 0.05. They already provide to us the range, we call that one, the status of our data set. If your KMO value macam yang ni, dia akan kirakan we have 5 variables. Each variable has their KMO value, and then they average this one. If the average of KMO value falls between less than 0.5, it will indicate that you don't have enough data. If the KMO value is between 0.5 to 0.7, it's Medicare, okay, can be accepted. More between 0.7 to 0.8 is considered good data. 0.8 to 0.9 is very good, and if you have more than 0.9, indicate you have an excellent data set, enough for multivariate data analysis. Unfortunately, in halal study, in food study, nobody has been reported this KMO value. This is the concern. That's why when we do a repetition, we cannot achieve the similar published papers because nobody have been testing to confirm whether their data is enough or not. If we compare to environmental study ni, they have a lot of data, and then they have collected 10 years. If you go to publication in environmental study, for chemometric analysis, environmental study have exceed the food study and halal study 10 years earlier than us. They are ahead 10 years of food lah. So, since I came from Jabatan Kimia Malaysia where we did for environmental study, so that's why I bring this one to food. Okay. So, it is indicate if you have KMO value more than 0.5, your sample is considered enough lah. So anything more than 0.5 until 1 is considered adequate for multivariate data analysis or chemometrics. So before we go for this evening, for PCA lah, discriminant lah, we will carry out this KMO first. If it is more than 0.5, you can proceed with your multivariate data analysis or chemometrics. If it is no, go back, enter your lab, do repetition. Collect more data. We want to have a result which is representable. So to have a representative data, you have to make sure the data that you have are really enough. Kalau tak layak lah untuk buat multivariate. Okay, so this is an example. The KMO value is 0.2086. Cukup tak data ni? Tak cukup So this is the question lah. So what we need to do if we analyze a data using KMO value less than 0.5, dia kena masuk. They need to go to the lab, do more laboratory testing, make more replication, adding more samples, and then go back to test the KMO value. Tak cukup ni sepatutnya tak boleh buat multivariate. That's why if I found a paper asking for me to review, I will recommend them to add this one. Okay. Sometimes people will be asking, kenapa nak pakai 0.01? Kenapa nak pakai 0.05? So we learn in our statistical analysis, when we have significant level alpha is 0.01, that indicate we have 99% correct results. If we have 0.05, that indicate we will get a 95% correct result, meaning that only 5% will become a potential error in our studies. This one is from statistical analysis we learned in undergrad. When we have 0.01, that indicate we allow to get 1% error in our study. Why I choose halal to be 0.01? Because I want my result to be correct at 99%. Halal kot. You jumpa je cosine, definitely dia terus haram. Dia tak adanya, alah cosine tu 1%. 1% je cosine tu. Kita memang takkan terima for halal. Kalau environmental study tak ada issue. There is no an issue. 1% je this dioxin tu boleh menyebabkan cause cancer, but only 1%. So should be bolehlah terima. Okay, but halal no. It's very sensitive issue. That's why I increase to 0.01. Unfortunately, starting from 2006, publication related to halal until 2000, I think 2013, most publications still use 0.05. They allow 5% errors lah. Yeah. So if you allow 5% errors, meaning that 95% of your data is enough, is correct, is not precise enough to make a database lah. So that's why I recommend go higher. If you want to go higher, you can make 0.0001. Yeah, it's 99.999%. So if you have a database, it's very accurate. Okay, so this is why we choose 0.1, 0.05, 0.01. Yeah, this is the meaning lah. Yeah. Most of the time when we learn statistical in our undergraduate, we are too focused on memorizing formula, never learn or be taught about how to interpret the results lah. Yeah. So in this workshop, we are not looking on memorizing formula at all. We are looking on if you get this value from this result, what does it means? Yeah. So we will look on that approach lah. Okay. Another prerequisite that people fail to follow is they don't make following the assumption of multivariate data analysis. In multivariate data analysis, the data should be normally distributed. They should also become homoscedasticity. They also shall have a linearity in this data set itself, the data set itself. So if your data is not normal, not linear, or you are heteroscedasticity data, only one step that you need to do is you need to do the transformation of your data lah. So transformation, there are lots of transformation. Yeah. Kalau you tengok dekat sini, for example, in the Excel stat, we can transform data into different way. We can go to this one, preparing data, variable transformation. The most common transformation is standardized n-1. N-1 is because our data is considered samples. It's not population. If it is population, it will become n only. Yeah. Another approach we can do for transformation is this one. Standardized center, divide by standard deviation, n-1, divide by standard deviation, and rescaling, Pareto scaling. These steps are another approaches for standardizing of our data set lah. So standardizing data will make sure that all your data follow normal distribution, all your data is homoscedasticity, and all your data are following a linearity distribution. Ini you boleh baca lah apa maksud dia. Okay, so enough with standardization of your data. You have to make sure it's normally distributed. Okay, yeah. That depend on your approach. Halal, I choose alpha 0.01. Environmental study, they prefer 0.05 only. You can go to not precise one, you can choose 0.1. If you choose 0.1, indicate you allow 1% error, 10% error. Meaning that only 90% correct. Yeah. But in halal, I have to be strict. That's why I put 0.01 lah. Because the topic is halal authentication. But we have to explain lah. Environmental study, they don't go to 0.01, they go to 0.05. Yeah. Okay, a little bit about homoscedasticity. Okay, orang pun akan tanya. People will be asking, apa homoscedasticity? Homoscedasticity is referring to the assumption that your data are evenly distributed. From the low concentration to high concentration, they are evenly distributed. So you can see here, daripada contohlah, as if this is our calibration curve. Remember we learned the calibration curve? This is our concentration, this is our area. As we increase the concentration, the area shall be increased. So it will be normally having an even distribution. So you nampak lah, it's like having a high distribution. But if it is heteroscedasticity, it's not normally or evenly distributed. Dekat sini, there are a lot data that not evenly distributed lah. They are concentrated more on here. It should be like this one. So to treat this one, this issue, you have to do a standardization. So this is example lah. Linearity is about the one that we have this calibration curve. You shall get a linear distribution, r square equal to 1. The one that we did the calibration is 0.998. So it's already informed that our data is linear. So this evening we are going to go for principle of chemometrics or for halal authentication and the practical number 4, which is discriminant analysis in halal authentication. So up to this slide, ada apa-apa nak tanya? Do you have any question? Petang ni kita akan buat we call it practical only. Done? Any question before we move to evening session? Kita akan stop dekat sini, but please install Excel stat first. Semua dah install? Done Tak boleh. Boleh doktor pergi, can you go to Excel stat? So in terms of principle of chemometrics for halal authentication, I would like to share about this one. You can have this. I didn't attach the link of this book. Okay. So these are the common types of chemometric approaches. So we can have a dependence method and interdependence method. So the one that we are going to learn this evening is about discriminant analysis. You will have one dependent and two independents or more, which is 2 or 3 more variables. And then in this evening, we are going to learn about interdependence method, which is principal component analysis. The aim of having this principal component analysis for the data reduction. For the earlier session, discriminant analysis, the aim of having this discriminant analysis for significance of discrimination. For example, we have 3 groups. We talked this morning. We have porcine, bovine, fish, gelatin or their oil extract. So we want to discriminate them. So to discriminate them, we need to use discriminant analysis. And then if we want to know which variables, which fatty acid methyl ester or which amino acid that characterize the grouping, we can do principal component analysis. So this first session we are talking about discriminant analysis first. So discriminant analysis in halal authentication is act as both explanatory and predictive technique, but it will predict our data or our unknown data qualitatively. Qualitative prediction or qualitative explanatory data. So we call it DA. DA identified the significant variable as well. We can know which variable are the most significant one or the most important in our study. That this significant variable contribute to each group sources. Group sources here is, as we say, we have bovine, porcine, fish. If you want to add plant extract, also we consider a source. Then if you have an unknown sample, this discriminant analysis will assist us on authenticate the unknown sample. So the good about this discriminant analysis, in one approach, they can explore your data, they can predict, and they can authenticate your samples. However, for any discriminant analysis, there are 3 types of data needed. The first one is training data set. Another one is validation data set. The third one is testing data set. So if you have a training data set will also be considered a database. Validation dataset is another dataset that we need to create to verify our database. Okay. Testing dataset is a dataset that we need in order for us we call it testing dataset is an unknown sample that we need to authenticate. Okay. So actually it has been explained here. Okay. So DA use the training dataset to develop the discriminating model. Discriminant analysis or DA as well will validate dataset. Will use the validation dataset to validate the discriminant analysis. Similar dataset uh, can be used as a training dataset as well. And validation of discriminant model using training dataset is known as cross validation. This is just a nomenclature lah. Okay. The new dataset with known this validation as well can also using a new dataset with known group sources. Okay. Then again, discriminant analysis will use the validated discriminating model to authenticate the group sources of testing dataset. Okay. And then testing dataset is also can be considered an unknown dataset. So if you have an unknown data, we can try to predict those data belong to which sample source. Okay, so this is just an explanation, the one that I have explained previously. Okay, this is just in the writing form. Okay, so when we conduct discriminant analysis, the first one requirement that we need to achieve, we have to make sure the discriminating analysis confirm 100% correct classification of the grouping. We have three groups, for example, porcine, bovine, fish, for example. So we want to confirm that they are correctly 100% belong to that particular groups. In this case, for example, I have three type of sample. First one is lard oil. Second one is palm oil. Third group of sample is we prepare a mixture of lard and palm oil. So the discriminant analysis, if they able to make 100% correct classification for all those grouping, that indicate your discriminant analysis able to establish a effective discriminating model. So this is the first requirement. Dapatkan dulu 100% correct classification. If your sample that you prepare is lard oil, you conduct discriminant analysis and they shall able to confirm lard is belong to lard. This is an example. I have 9 lard sample, 9 lard oil prepared. So when we conduct discriminant analysis, 9 lard is correctly classified as lard. So that's why we get total 9 and then correct 100%. I have also prepared a mixture of lard and palm oil. So total sample that I have prepared is 27 and it is correctly classified as mixture of lard and palm oil, 27 of them. So it's 100% correct classification. The third one, I have another sample from plant extract, which is palm oil. So I have prepared 9 palm oils and then using the discriminant analysis, they have correctly classified all 9 palm oils belong to palm oil itself. So if we average all of them, we get 100% correct classification. So first requirement of discriminant analysis has been established. You have established one discriminating model, a good one. Okay. Beside of that, we need to ensure the Fisher distance test at 0.01 between grouping are significantly different. Okay, how to confirm it's significantly different? You have to look at the p-value calculated. If the p-value calculated is less than 0.01, this 0.01 is the one that you set. 0.01 mean only allow 1% error, or you want to achieve 99% correct classification. The p-value shall be less than 0.01 to confirm that you have a significant variable contributing to the three groups: lard, palm oil mixture, and palm oil. Okay. Another requirement that you need to achieve is the p-value shall be less than 0.01 using a Weeks lambda test that reject the hash null. hash null mean hypothesis null. The another hypothesis, we call it hypothesis alternative. Okay, how to know this one? The good thing about SL stat, they will provide the hash null and hash alternative to you, and then they will calculate for you. They will interpret for you as well. We will look later in the uh, hands-on, yeah, in the practical one. Okay, so from this result, the DA has successfully developed a discriminating model lah. Okay. Sekejap. Okay, so this is an example lah. P-value which is less than 0.01. So the one that we calculated here is less than 0.001, which is smaller value. This is the Weeks lambda test produced by Hexelstat. So on the previous note, we say P-value shall be less than 0.01 and it will indicate rejection of hash null. So you can see in this example, in Weeks lambda test by Hexelstat, they provide to you the hash null. Okay, the hash null say that the means vector of the three classes are equal. Three classes is belong to what? Group of lard and palm oil mixture and palm oil. So we have three classes lah. Yeah. The means vector of three classes are equal. There is no significant difference between this grouping as stated by hash null. But hypothesis alternative, or we call it hash A, say at least one of the means vector is different from another. We want to prove at least one of the group are different from another lah. But in this case, we want all of them are different. Okay. So the Weeks lambda test will be calculated. You can get the p-value here. So the p-value calculated is 0.001. The one that we have set is 0.05 or 0.01 here. So you can see it's too low compared to the one that we have set. You can read at the bottom on the interpretation by the Hexelstat as the computed p-value, which is this one, 0.001, is lower than the significant level set up, which is 0.05. As I'm sorry, it should be 0.01, but this is another example of 0.05. One should reject the null hypothesis HO and accept the alternative hypothesis. So if we are rejecting hash null, that indicate we have to accept hypothesis alternative, which say at least one of the mean vector is different from another, meaning that at least one of the group are different from another. That indicate the three groups are really significantly different from them. Okay, so beside of that, we want to identify among the variable that we use in this study, which variables are the significant one that contributing to the discriminating analysis. Okay, so you can go to find from the results of unidimensional test of equality of the mean of clusters. Classes mean grouping lah. So the variable with p-value less than 0.01 indicate significant variable that plays role in the discriminating model. So in this case, you can see we have out of some variable that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Only 1, 2, 3, 4, 5, 6, 7. Only 7 variable are significant. So that indicate we can propose to any of our laboratory or in our study, instead of we run 13 variables, is it 13? Okay, 11 lah, for example, 11 variables. Actually, only 7 variables are needed for our study. So we can reduce costs, no hassle on getting results, and so on and so forth. Similar like what we did in Jabatan Kimia Malaysia. For environmental study to monitor the pollution in Malaysia, our government sending samples to Jabatan Kimia where we analyze almost 30 variables, 30 parameter for water, pollution in river, for example. But it's very costly. So we get all those data within 10 years. We carry out discriminant analysis. rupa-rupanya only out of 100 variable, for example, or 30, 17 variable only needed to monitor pollution in Malaysia. So we proposed to Department of Environment, so we managed to cut costs for the government for monitoring pollution in Malaysia lah. Similar like this, you have lots of variables, yeah. For example, in fatty acid, we have 37 fatty acid. But to differentiate between sources of samples, perhaps not 37 significant one in our study, perhaps 10 only. So instead of we purchase 37 fatty acid standard, just purchase 10. Yeah, but we cannot achieve this 10 before we carry out a higher number of fatty acids analysis, and then from using discriminant analysis, they will propose to you which are the significant variables. Okay, ini faham Okay, beside of that, we will look later similar plotting like this in principal component analysis related to the correlation. Okay, so you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10, only 7 are significant variable in our study. Okay. Okay, in terms of result from discriminant analysis, they will provide the grouping that we are looking for, the significant grouping. So you can see here on the left side, it is a lard. In the middle one is lard and palm oil mixture. The right side is palm oil. So if you have a sample, unknown sample, you analyze again with the similar discriminating model, it will show you where your unknown sample fall. Okay? So you can see here this blue in the round shape symbol. Okay, it is the lard. Green is lard and palm oil, and then green, I think it's green, fully green, is palm oil. So you can see that they have prepared developed their own specific grouping, and then at the bottom one, the three bottom, we have a square size sample predicted as lard. There is also lard and palm oil predicted one, and also palm oil predicted one. This one is actually a prepared unknown sample. We just try to validate. Okay, so we can see that they falls into their grouping lah. Lard is here, lard and palm oil is here, palm oil is here lah. So if you have an unknown sample and that those unknown sample falls in the lard group, that indicate actually your sample containing lard. Or your sample falls onto palm oil group on the right side. So that indicate the oil that you have is containing palm oil. If you find out there is also a sample falls in the middle one, that indicate perhaps there is a mixture of lard and palm oil. Okay. Logically, if you have left side is lard, the right side is palm oil, mixture will be in the middle. Okay. So that's how we in the laboratory testing, we would like to use this method to predict whether the unknown samples actually containing non-halal source or not. Okay. And then if you look deeper in the middle one, there is a yellow circle with green color. Okay, that one we call it centroid. Okay? So it will be represented with another plotting. So they plot the centroid only. So you can see there are three different grouping using the centroid plotting. Okay, just to show you. Okay, we have that significant grouping. Okay. So this is how discriminant analysis result looks like lah. Okay. Okay. Then this is another example. For example, I prepare an unknown sample. A known sample. The first five is palm oil. The middle one is mixture of lard and palm oil, LP, and the bottom one is lard. And then I'm using the similar discriminating model to predict, are they really correctly predict your sample. So you can see palm oils predicted is the one that you prepare. The predicted one is in this column. So you prepare a palm oil, you get a palm oil. You prepare a mixture of lard and palm oil, you get a lard and palm oil. You prepare a lard, and then you really get lard predicted value using your discriminant model. Usually you can achieve this if your discriminant model at the first place fulfill this requirement. Yang ni If you achieve correct classification here, usually you have successfully developed a good and effective discriminant model lah. Okay. So this is an example. Yeah. It's up to us, no problem. Okay. But if as I told you, more repetition is better lah. Yeah. Kejap. Okay, remember we talked about this one? Discriminant analysis need training, validation dataset, and testing dataset. Testing dataset is your unknown sample, but for us to develop a database for the model, we need a training dataset. So make sure you have high numbers of training data, so that you can get. Remember this morning we talked about 40 gelatin, 40 gelatin, 40 gelatin. So they have 120 gelatin as a database. So for this training dataset, the requirement is prepare as many as possible training dataset. For testing dataset, it's okay because it is unknown. We just want to check they belong to which group lah. Yeah. Okay. So now we reach to the practical discriminant analysis. Okay. To avoid mengantuk, sleepiness. Okay, we go for discriminant analysis in halal authentication. Okay. So before that, let me introduce us first. I have prepared a data, which is we mix the palm oil and lard, and we are going to use it to discriminate the grouping. Okay, so the data that I have shared to you using the fatty acid composition of mixture of palm oil and lard, focusing on authentication of the palm oils, indicate like people are selling palm oil, but actually they just contaminate or pollute them with the lard. And usually that doesn't happen. Usually we pollute palm oil with olive oil. That one is common, but we never pollute palm oil with lard. Yeah. But for the sake of simulated data, because we have the expert here, so she will be marking that's wrong. Okay. But for the simulated data, I just show you the how we can do this discriminant model. Okay. So let's go to our file. Go to the folder that I share with you. This one. Data for chemometrics. Okay. Actually, we only need two Excel file. You can see here discriminant analysis, PCA, PCA. But if you can see, the type is different. For Excel stat, for them to be operated well, you may need to use Microsoft Excel macro enable worksheet. Okay, so in this study, in this workshop, we are going to use discriminant analysis and principal component analysis with this type, Microsoft Excel macro enable worksheet. I also provide you the similar file but different type because some of us may not encounter that problem. If you encounter the problem on the macro enable something related to your Excel, recommended you to use Microsoft Excel macro enable worksheet lah. Okay. So for this session, please click simulated data discriminant analysis number 1, the number 1. Okay, so if you see here security warning macros have been disabled, just click enable content. Kalau jumpa this one lah, if there is no problem, you just open it as it is lah. Okay. So now, if you can see, The one that I have shared to you, actually we only need this, all data. You only need this. But if you can see the rest, variable transformation sheet, DA, significant variables, DA1, DA2, actually the one that I have prepared for you as your reference. Okay, so you can do the same, and then if you want to refer, is it correct or incorrect in terms of result, you can refer the one that I have prepared here. Kena charge lebih ni dah buat dulu. Okay. So for this workshop, okay, this is actually, let's go about the data. Okay, this is the original data. It's not original actually, simulated data. Okay. We have prepared palm oil, a mixture of palm oil. You can see here. Okay. At the left side is the ratio of the lard and palm oil. If you can see here, this one, LP2 -1, 25% of lard is mixed with 70%, 75% of palm oil. This one. Yeah. So we have prepared as well different ratio, 50-50, 75-25, and then 100% lard. The top one is 0% lard but 100% palm oil. Okay, so this is the sample that we have prepared for you. So you can see at the column we have C15 until C18. So these are the fatty acid that I have selected. There is no reason why I choose this one. I just want to do this one for our study. So I just choose these numbers of fatty acid metal ester. There is no scientific evidence. It's just for the sake of simulation study lah. Okay. And then I have prepared a grouping column. I just want to tell them this is palm oil. This group is lard and palm oil. This group is lard. Okay, because we want to use this grouping for discriminant analysis. Okay, so if you can see at the top here, we state here this is training data set. Okay, data set. And then I have prepared a validation data set as well. Okay, so this is actually I have prepared a known another set of palm oil, lard and palm oil, and also lard. Okay, but a smaller size lah. Okay, and then I have prepared a testing data set. Okay, actually this testing data set shall be using an unknown sample. But in this study, I prepare the known one. We just assume it is unknown. But we claim it's a testing data set lah. Yeah. Okay. So what we shall do, okay, this data set shall be transformed first. Yeah. So if you go back to all data sheet, the data that I have shared is actually already transformed. So it's already transformed. But if you want to know how to do the transformation, like this one, boleh klik kat sini, go to Excel tab. We try to do the transformation, but the data that we are going to do for discriminant analysis already transformed. I just want to show where to go for transformation. Okay. We assume this data, training data set is not transformed yet, and we want to transform. Okay. So you go to Excel tab, open the Excel tab symbol here. It's not symbol, icon. Okay. Okay, and then you have a preparing data set. Go to preparing data. Go to variables transformation. Okay. So it will appearing a small window. Okay. So on this data part, click that, and then go to the title of the title of the sample name. Sample name C15.0, drag to C18.3 and 6. Drag first and then drag down until the last column or the last row of the training dataset. Okay. Go here. C15.0. Yeah. Preparing data. Yeah. Sorry. Preparing data. go to variable transformations. Yeah. Okay. Okay, before we move that, okay, you might be asking why we need this data transformation. Go look back to the previous note. In the previous note, this morning we talked about the requirement to have performing assumption of data set. Your data should be normalized. So standardizing the data using transformation is normalizing approach lah. This is a compulsory to do it at the first place. Yeah? But the data that I have prepared to you already transformed. But I just want to show you where to look, where to go to Excel step lah. Okay. All right. Okay. So when you open this one, preparing data, go to variable transformation. Okay. For the data part, click that button. Go to C15.0, drag to 6, 18, 3, and 6, and then drag down to the last row of the training data set. This is training data set. Then click column labels, tick column label. You need also to tick observation label. And these observation labels, meaning that this is for your sample name. So you click at the right part. Go to the sample name. So go to the title of the sample name, sample, drag down to the last name of sample. Okay, done? Done? Okay. On this right side, you can see there is a range, sheet or workbook. This is a place that how do you want your result to be look like, to be produced? If you choose range, you have to click at the Excel cell at the bottom so that the result will be appearing there. If we use sheet, the result will be displayed as a new sheet like this one. If you choose workbook, your result will be appearing in another Excel file. So this is how you want your result to be appearing. That's why I prefer to use the Excel tab. At least I know and I can explain to you why you choose to click this one. It's not like the SIM card because I don't know why the button is there. Okay. Okay. So you need to click as well this one. Display the report header. That's no problem. Transformation, we click standardized N-1. Standardized N-1 is the most universal transformation method lah. If you don't want to use standardized N-1, you can click other. And then you can, if you click other, the transformation tab here will be activating. And then you can choose other transformation method as well. And this is another alternative. Yeah. But in general approach, people will go to standardized N-1. Okay. And then you can click okay. Go to missing data. Not yet. Missing data. So this data has been treated properly. So you can click do not missing data. Okay. Other option, if you have missing data, you can choose remove observation. You just let it be, ignore, just produce result, ignore the missing data. You also can choose here, or you can even estimate the missing data. If they estimate the missing data, they will produce a mean value for that missing data lah. Yeah. So usually before we carry out multivariate data analysis, make sure you treat your missing data first. You want to remove the outliers, so on and so forth, you have to do it first. Yeah. But in this case, no missing data. When I prepare this simulated data, so I choose do not accept missing data lah. Yeah. And then you need to click OK. And then there is also one window will appear. Okay, so they will tell you how many data that you have. 45 rows, meaning that you have 45 samples. You have column, meaning that you have 13 fatty acid metal ester. Yeah. Observation levels, you have 45 because you have 45 samples, and then column only one because your sample name is only one column here. Okay. Senang kan? Senang nak explain kan? Sebab tahu nak tekan apa. Okay. So you can click continue. Okay, is it appearing like this one? Okay, so you can see it appearing as a new sheet. Sheet. But the title is variable transformation 1. Why there is 1? Because I have prepared the first one for you, variable transformation. So each time you produce a new sheet, if the name's already there, so it will produce a variable transformation 1, transformation 2, transformation 3, yeah? So you can refer back how the one that I have prepared for you lah. Okay. So we go back to the original data. This original data has been transformed for you lah. Okay, so you don't need to transform each time for this workshop lah. Yeah. Another thing, a good thing, because I don't want to give the raw data. Okay. So after completion of this one, let's go to carry out discriminant analysis. Okay, before that, if you go to the bottom sheet DA, there is a DA there. Click DA. So this is the result of your discriminant analysis. Yeah. We want to achieve this lah. So to get this result, go to all data. Go back to all data. We want to do discriminant analysis. Go to analyzing data. Done. Click discriminant analysis. Okay. So again, if you want to do discriminant analysis, go to analyzing data. Choose discriminant analysis. Okay. Done. So you can see there is a window there. This window, there is the first thing that you need to fill in is the y, which is dependent variables. So this y actually is the grouping of your sample. Where is the grouping? This column group that I have prepared for you. Okay. So that's why we need to prepare this grouping column first. Okay. So you want to tell the system these 45 sample having 3 groups. So prepare this grouping. And then make sure if you choose palm oil, there is no palm oil 1, palm oil 2. No, that's wrong. Palm oil. Lard plus palm oil, itu sahaja, only that. If you go for lard only, no lard 1, lard 2, lard 10, no, that's wrong. Okay. So go here, click that, go to the title of the group, drag down to the last training data set, the lard. Okay. And then on the X data / explanatory variable, so they want you to choose the variable in this study. So which variable? The fatty acids. Yeah. So click quantitative, because the fatty acid that we have having their own concentrations, so it's having some value, so it will be quantitative. Click that one, this one. Go to again to C15.0, drag to C18.3 and 6, drag to the right, and then drag down to the last fatty acid for that training data set. Boleh? Done? Done? Any problem before we move? Yeah. Sekejap. Observation label you have to take. Click balik, this one. Go to sample name and then drag down to the last sample name. Okay? Done? Okay. So we have training, we have validation, we have testing data set. So the one that we are fill in now is using training data set that will become the database. Kena ulang banyak kali ni, hafal tau. Esok jadi team saya untuk jadi trainer sales stat ni. Save record Okay, and then for options, this one, just let it be 0.01 on tolerance. You just let it be equality, prior probability, let it be, just tick. Similar like this one. Significant level, choose 1%. Yeah, this is halal authentication kan? So I prefer to use 1. But actually, it's up to you. If you want to use 5, it's okay. You just have to put significance level 5. Yeah. Model selection, let it be. Yeah. The rest as well, let it be. Similar like this one. Validation. Okay, for validation, we don't want to do validation here using this feature. Kita tak nak buat. But we will use the validation data in the prediction part nanti. Okay, so let it be validation. So if we don't take this validation, the DA still do cross validation for us. But we won't use that result in our production lah, in our publication. But the system will still do for us. They will display the results for us. Yeah. But we don't want to do validation using this feature. We want to use validation data at the prediction part. So go to prediction. Click prediction, and then click quantitative for the X. For explanatory variables, click quantitative. Okay, click that one. Go to the validation dataset. Okay, bawah ni we want to use this validation dataset as a prediction. Okay, this time don't click C150. Click the another cell, the bottom, the lower cell. Click this one. Drag to the right for the last fatty acid metaester, and then drag down to the last sample. Okay. So again, for this validation tab, we are not going to use it, but the system will do for us, which is the result will not be used in this workshop. Yeah? But I want to use the validation dataset as a prediction. Yeah? So what we need to do, click prediction on for this part of X explanatory variables, quantitative. Click here, and then you need to click. Kenapa dia ke situ? Oh, this one. Click the cell below the C15. Drag to the right. Dia lain sikit on this part. It's not the similar like the training dataset, and then drag down to the last validation sample. Okay. And then for observation labels, you have to tick as well. And then click at the right part. This time, click the sample name, P110. Do not click the sample name, sample title. Go to P110 and then drag down to the last. It shall be tally with the cell that you set for your variables lah. Yeah. Done? Okay? Boleh? Okay. Missing data, you just choose remove the observation. Yeah. Variable labels. Record balik, okay. Sekejap, ulang balik. Okay, for missing data, choose remove the observation sebab tengah record, sorry ulang balik. Sebab tadi pergi pause. And then for output, click je semua. Click all the boxes. Okay. And then for charts, click all boxes including n first rows ni. And then please putting or key in the number of observation type 100,000. Type 100,000. Yours is what? Okay. Actually, you can put 100. But if you accidentally having larger samples, they only process the first 100. Kita ni prepare for the worst. Dalam hidup, prepare for the worst. So, putting as much as possible, 100,000 data sets. So, and then click OK. Okay, so it will appearing this window. So, you have qualitative 45 rows because 45 samples. X is quantitative 45 samples with 13 variables. Observation level is 45. And then for your prediction, which is for validation, you have 25 samples, 13 variable as well. And then observation level, you have 25 validation data set. Kira sama tak? Katanya okay. Okay, and then you try to click continue. Dapat? Do you get this one? F1, F2? So, why there is F1, F2? Your result will be plotted in two dimensions, which is Paxi X and Paxi Y. Axis X and axis Y. So that's why you get F1 versus F2 lah. There are two axes your result will be plotting. And then if you can see there is 100% mark there, that indicate total of your fatty acids are really meaningful in this study. But we still can identify the most significant one when we evaluate the results. Yeah? So click select and then click done. Okay, done. Done. So you will get the A2. You will get the A2 Yeah, betul. Sekejap. Okay, let us continue for explanation this one. So we have the results of discriminant analysis. So the one that we have prepared is actually DA, the bottom one, the sheet DA, but the one that we created just now is DA2. Why there is a DA2? Because if you go back, you go on the right side, we have DA, DA1 and DA2 with testing data set. So that's why when the system create another DA, it will produce a new name as DA2 lah. So in terms of explanation and result, DA and DA2 are similar results lah. Okay, so I will open DA here to explain. So this is the result that we get. Summary statistic, how many samples that we have prepared in this study. So lard we have 9, lard and palm oil mixture is 27, and then another palm oil is 9. Okay, and then you can see those variables that we have is 13 variables, which is fatty acid methyl ester. Okay, and then you can see the observation with missing data, so on and so on. This is just a descriptive information. Okay. And then for the correlation matrix, you can see here, they try to provide us with information among the fatty acid methyl ester, what are the correlation between them. Okay, yang ni. So usually, if we have correlation matrix, CM, correlation matrix, more than 0.7 is considered strong lah. Yeah. So low than that is moderate or less. If you have CM, correlation matrix, less than 0.3, it is also considered weak. Yeah, those between 0.7 and 0.3 is considered moderate. Another one, this correlation matrix is absolute value. It is absolute value. Pernah dengar tak about absolute value? Absolute value means if you have negative or positive value, you don't take the negative value. Yeah, you just take as absolute value lah. Okay. Model saya betul. Macam tu saya pun tak ingat. Okay. So if you have correlation matrix here with negative value, okay, it just indicate you how proportion or inverse. If we have negative sign, that indicate inverse correlation lah. For example, kita pergi cari yang strong sikit. Okay, this one. C20 0 and C16 0. C16 0 is hexanoic acid. In palm oil, hexanoic acid is the most common lah in any palm oil lah. Okay. So you can see the correlations metric here is 0.8246. So C816 and C20 having a strong correlation. However, they are inversely proportional. Meaning that in our study, if we have high concentration of C16, we definitely will have low C20. That's how we explain lah, because of this negative sign. Understood? Faham? Okay. Okay. So for us to know the strong correlation, moderate correlation, weak correlation, saya tulis kat sini sekejap. Okay. So for us to know whether it's strong, moderate or weak, correlation matrix here, which having value more than 0.7 is considered strong. Any correlation matrix between 0.3 to 0.7 is considered moderate. And any correlation matrix having a value less than 0.3 is considered weak. However, if you look at the correlation matrix, if they have a negative sign, that indicate the correlation is inversely proportional. Dia berlawanan arah. If there is no negative sign, meaning that it's positive sign, that is indicate they are proportional. So we put an example. We have C16 and C20. So C16 is hexanoic acid, which is the common indicator of plant, fatty acid in plant. They have a correlation with negative 0.8246 against C20, but the sign is negative. Since the value is 0.8, so they belong to strong correlation. They have strong correlation between C16 and C20. However, this correlation is inversely proportional because it is negatively signed. This one, negative 0.82. They are strong, but negatively proportional or inversely proportional. In explanation, if you have high C16 in this study, you will definitely have a low C20 and vice versa. If you have high C20 in your sample, you definitely have a low C16 in your samples. In all your samples, all samples. Whether it's lard, palm oil or lard and palm oil mixture. This is in general, according to our sample that we have. So how about if we look at this one? C70 against C17 1. Okay, so the one that we have here, the value that we have here is 0.9556, indicate C17 and C17 1 having a strong correlation which is proportional to each other. If in our sample we have C17 we also will have C17 1 high concentration C17 1 in our sample. So that is how we interpret. Okay, so this is a correlation matrix explanation. Okay, so this is the lacking that we found. When people receive this kind of result, they don't know how to explain. So I hope that we can capture the gist of it. Okay. Then we also have discriminant analysis explanation. This the bottom part is specifically for our discriminant analysis. The top part is more on summary statistics. So for explanation of discriminant analysis, it starts at this part. Okay, so you can see the means by class. So they will try to identify for C15 what is the mean value in lard for C15. What is the value of the mean value for C15 in the lard and palm oil? So you can see here, for example, we can see in lard and palm oil having the lowest C15 compared to lard, even in the mixture. Okay, so this is an example how to explain that. Okay, then sum of weight, prior probabilities, and logarithm. This is not being used for explanation, but it will be used in the other calculations. Yeah. The one that I want to propose to look at the discriminant analysis is this one. Okay. Yang ni, Fisher distance. Okay. So you can see here, we want the system, we want to tell them we have three type of samples. Can they differentiate these three samples, these three group of samples? So it based on Fisher distance. Yeah. So you can see this Fisher distance, they have some value. The higher the value here indicate the far the group from each other. For example, can you see here? Lard against palm oil, the value is 14, but palm oil against lard and palm oil mixture is 7.20, which means the group of lard is nearer to lard and palm oil mixture lah. Yeah, dia lebih dekat in term of grouping location. Okay, and then we want to know how significant the samples grouping to each other, the differences. Okay, it based on the p-value of Fisher distance. We talk about this in the sharing note. Yeah. The lower the value which is less than 0.01, because the significant level that we choose in the study is 0.01, remember? Yeah, 0.01. But the calculated one is less than 0.001, which is very much smaller. So when you see palm oil against lard with this value, that indicate the group of lard and palm oil mixture are really significantly different. You can see again, lard versus palm oil. Yeah, the value is less than 0.001. That indicate lard and palm oil also are significantly different from each other. So this is one of the requirement that you need to achieve lah. Okay. Then we can confirm these differences using the Weeks lambda test. Yeah? So with this Weeks lambda test, they provide the mean vector using the H null, which is three classes are equal, and the one that we want to prove is the hash alternative. At least one of the means vector is different from each other. We want to confirm the group are different from each other, so we want to prove the hash null is correct, is valid. So they calculate for us the p-value. The one that we calculated is 0.001. And then you see at the explanation at the bottom, the alpha that we set is 0.01. Sekejap ya. So if you see here, the calculated one is here. You read at the explanation at the bottom, as the computed p-value, which is here, is lower than the significant level set, which is here, 0.01. We shall reject the null hypothesis and accept the alternative hypothesis. So the one that we are going to accept is this one. So that indicate at least one of the means vector is different from each other. That indicate those three groups are really significantly different. Yeah, because we want to use this training data set as a database. Okay, so one achievement. Yeah. Now we want to know, among all those 13 variables, what are the most significant variables? Okay, we need to refer to p-value. How to refer at the p-value? The one that we set is p less than 0.01. So any p-value which is less than 0.01 is considered significant variable. So which one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this 9 out of 13 variable that we start at the initial of our study, unfortunately 4 are not significant, only 9 are significant. 9 are most significant and important lah. So we can cut short in terms of analyzing time. Remember, we do the analysis with GCMS. We need 1 hour. So use 9 significant variable. Perhaps we can cut short until 30 minutes only. So this is the way we make an effective way of research lah. Yeah. Uh, okay. Beside of that, we can also know the significant variable by looking at the F value here. F value is the apa dia panggil? F statistic value. Okay, the higher F statistic value indicate the most significant variables. Okay, so macam mana nak buat? We can rearrange this F value. How to rearrange? Highlight down, go to home, sort and filters, choose the largest to smallest, and then expand the selection. If you see back on the, after we rearrange the F statistic value, you can see the p-value also will be rearranged. So all those 9 variables have been relocated at the top of the table. So if you want to, instead of just do pointing here and there, you can rearrange the F value according to the highest to the lowest one, and then you can get the most 9 significant variables in our study. Okay, then okay, what else that we can interpret? Okay, remember what we did in the DA? We have training and validation data set. So we want to see how good they are in validating our this model, in validating the data set. Okay, so you go to the bottom part, which is, we call it this one. Not yet. We go to confusing metric for training data set first. So we prepare 9 LUT in the training data set, and the model, discriminating model, able to confirm 9 of them are really LUT. So we get 100% correct. We prepare a mixture of LUT and palm oil, 27 of it, and it is confirmed all of them are mixture of LUT and palm oil. We prepare another 9 palm oil, and then the discriminating model confirm all of them are palm oil. So 100%, 100%, 100%. You make an average, so you get 100% correct classification. You have achieved a good discriminating model in this part lah. Okay. Then let's go to the prediction samples yang ni. So these prediction samples actually came from our validation data set. Yeah, this one yang ni. Remember any validation data set? We prepare the palm oil and we want to know, are they able to confirm that palm oil? Okay. So we have 5 palm oil. All of them are palm oil. We prepare, ni berapa 15 mixture of LUT and palm oil, and all of them are predict successfully. We have 5 LUT and they are also predicted or validated as LUT. So 100%, 100%, and 100%. So you have developed a correct classification model. Okay. So macam mana how we produce a papers from this one? Paling mudah tunjuk saja. Okay, so we go to this paper. Contoh ya. Oh, this one. This one. So, This one I don't use the palm oil. Sorry, other palm oil. I use the gelatin. So this is how we use the result. The percentage. This one, yang ni, this one, we convert into this results lah. Training data set, validation data set, testing data set. So we have 100 correct classification, numbers of prepared sample. You put again in this part your p value of Fisher distance. So this is how we, and then your significant variables, you note that you prepare, you have 13 fatty acid metaester, and then you bold the result, the significant one. So this is how we put a report lah. Okay. The way we explain is the one that I shared to you. Okay, never mind, I have recorded this one. So okay, and then total of this one gelatin. So total of your sample, you can you have 40 porcine, you have 40. 80 non-porcine gelatin, you have 80. So if you have a mixture, you have 120 lah. So this is how we make a publication. But in this case, I even verify with actual sample. This is gelatin. So after we carry out the validation with the training and validation data set, I prepare a gelatin. I prepare a marshmallow. Kita buat marshmallow using the gelatin from different sources, and then we extract again, run again with HPLC, and we verify again with actual sample, because this method will be used in laboratory testing. This is for JAKIM lab. So we want to confirm, are they able to differentiate on actual samples? But you can see it will be reducing from 100% in actual gelatin, but when we make in actual sample, they drop into 96% correct only. So this is the challenge about laboratory testing lah. In actual pure palm oil, for example, you will get 100%. But when you make into a cosmetics, we make into butter, gelatin, any margarine, for example, using some palm oil, you will get a reduction value in actual samples lah. So this is the confirmation how good you are with your discriminating model, how good you are in of explaining it, but you still might face challenges in actual samples. So take note on that lah. No limit, doctor. So far, no. Quite okay lah. But there is no limit. Nobody have been publishing. There is some limit, because when we talk about halal, there shouldn't be any limit. There is porcine, shall be porcine. Why we get only 96%? I prepare a marshmallow using a porcine. How much is it? 30. Only 22 are correctly porcine. 2 of them are actually not identified as porcine. It's identified as non-porcine. So halal issues, it shouldn't be. It should be porcine. So this is the challenge. But if I prepare a non-porcine sample, 20, they are correctly classified as non-porcine. So this is the challenge. So this is how we look on the results lah. People will very likely to publish papers when you can prove in actual samples. Even how bad it is, but if you can use on the actual sample, people will put, okay, at least someone have been tested on the actual one. We don't merely claim here and there, writing everything will be top of the sky, but in actual sample, nothing can be produced. So this is an example. Okay. This can be used, but still in the, we call it method progression. There is still, if the aim is we need to maintain 100% as the training and validation data set. Similar with this data, as we saw, they achieve this 100%. Even when we ask them to predict, they able to 100% predicted. But how about we use the lard and palm oil, prepare a cosmetic, extract again, run again, esterify again using GCMS? Are they able to do the same? Usually no. matrix issues, because in actual sample there are a lot of ingredient being added. Sometimes we have preservative, even sometimes in the sample we have bacteria where they fermented, they also have their own fatty acids. Yeah. So if you could explain what are the potential that contributing to the uncertainties like this one, at least people will take note why. Uh, if you are preparing fresh, perhaps you have a higher accuracy. But if you have that cosmetic, which we know the shelf life is 6 months, and then you run again after 2 months, run again after 4 months, definitely you will not get the 90% anymore. Bacteria will start grow. They also have their cell wall. They also have their own fatty acid. They will contribute their fatty acid to our cosmetics product. Okay. So this is the challenge everybody to go for halal lah. Unfortunately, for oil sample, if you people will go for halal testing using PCR, polymerase chain reaction, DNA test. Unfortunately, in oil samples, it's very hard to extract DNA. So that's why people go to fatty acids. But that's also another challenge. Yeah. In cosmetic as well, we have 40 to hundreds ingredient in one sample of your moisturizer cream. So in that moisturizer as well, they have the inhibitors, where if we want to conduct a DNA test, the inhibitors will inhibit the amplification of our DNA. So that's why people will go to DNA, fatty acid using GC. But this is another challenge in actual samples. Okay, ini dah 335, okay. So I think we move to next part. Is it okay? The last part. Semua orang nak balik kompat kan, lama tak sempat. Ada setengah jam lagi. Okay. So the next part is principal component analysis. Okay, we have some talk, a little bit sharing, and another hands-on. Okay, so again, this PCA, or we call it principal component analysis, they are in the part of interdependence method, meaning that we also call them unsupervised method. Why we call it unsupervised? Because we don't tell the system this is which group. Compared to discriminant analysis, they are also acknowledged as dependence method and supervised method, because we tell the system, okay, this is lard and palm oil mixture, this is palm oil. For PCA, we don't tell the system what are those sample are. We let the system do the analysis for us without telling them. So that's why we call it interdependence method, or we call it unsupervised method. Okay. Okay. Usually people will go for PCA at the first place on want to explore what do we have in our sample. So they just go to PCA because they don't want to discriminate anything. So we just go PCA to find any significant variables. Yeah. Okay. So what the PCA does to our multivariate data? Okay. This is an example. We have gelatin. We have amino acid data, 13 amino acid, original data. So when we conduct a PCA, this PCA, or we call it principal component analysis, will produce a principal component. Number of principal component is equal to number of variable that we introduce to the system. If we have 13 amino acid, the PCA will produce 13 principal component. Principal component also will be called as factor. And that's why in the result of PCA later, it will not label as PC, it will label as F. F mean factor lah. So factor or principal component is the same lah. Okay, sama. Okay, so From this PCA, we can usually PCA will go for high numbers of variable and high number of samples. We can pick up significant variable contributing in our study and by reducing the dimension lah. Okay, so okay, this F1 until F13 is the principal component. So actually, we can plot this 13 component equal to 13 dimension. Faham tak? 13 dimension. Okay. So it's like this one. Okay. Contoh it's like this one. If we have two dimension, we will have paksi X and paksi Y, correct? If we have three dimension, we will have paksi X, Y, and Z. If we have 13, okay. So the result can be plot up to 13 dimension. Why 13 dimension? Because we have 13 variables. But instead of plotting until 13 dimension, not all variables are significant. So that's why people will go to pre-simple component analysis and they will pick up only significant variable by reducing the dimension number. So usually people will only plot two dimension, which is F1 versus F2. Oh, panjang pula. Sorry. Sini je. F1 and F2 only. Okay, we don't plot until F13 lah. So we will get a result macam ni saja. Usually, those variable which is the significant one will be located at F1 and F2. So from there, we can select which are the significant one lah. Okay. Okay, how the result looks like? So the result will look like this one. There are three plots that will be provided by the PCA, any PCA actually. So you can see on the left side, we call it variable plot. We can see as an observation plot, and we also can see a bar plot. Okay, so soalan lah. Okay, it's like this. How to interpret? It's like this. We conduct amino acid analysis in porcine, bovine, and fish gelatin. So it will produce a bar plot like this one, for all these three groups lah. Okay, but we don't tell the system we have this type of three groups because this is unsupervised method. So it will produce the arrangement of the variable according to factor loading. So the factor loading will be plot like in the variable plot like this one. So you can see the way to interpret any variable, any amino acid that stays together or located together are positively correlated. That indicate this one, methionine, THR, serine, and histidine are positively correlated to each other. Indicate that as well. If the sample containing high methionine and high thiourin, it also contain high serine and histidine. They are positively correlated. Yang ni tinggi, yang tu pun tinggi. Beside of that, any amino acid that falls in the opposite direction, which is hydroxyproline here in this case, they are opposite direction of these four amino acids that indicate they are negatively correlated or inversely proportional. If in the sample, it contains high methionine, high thiourin, serine, and histidine, the sample might be containing low hydroxyproline. HYP is hydroxyproline. Okay, faham? So, what are the variable that may stay together and having positive correlation? This one. Liu and PHE. TYR and PHE here, sorry. Alanine and LYS, saya tak ingat lupa dia. Okay, GLU is located nearer. So they are positively correlated to each other. This one also positively correlated. This one as well. Ni tiga ni lah boleh. Okay. Okay, sekejap. Kita pergi dekat Okay, there is one information that most of people didn't or have neglected. Okay, the direction, with this one we call it vector. The direction among the variable itself also indicates something. Any variables, any amino acid having almost 90-degree direction, 90 degree darjah ni, indicate they don't have any correlation at all. That indicate hydroxyproline against alanine and LYS here doesn't have any correlation. So that is the lacking of people that publish using PCA. They only looking for positively correlated. They don't even look at the negative correlation, and they don't even look at is there any significant with other variables. So this is another information that people lacking. Okay, so that is the most part on variable plot. Beside of that, we also have another plot, we call it observation plot. Observation plot meaning that your samples plotting lah. So you can see at the plot on the right side is the fish gelatin. That's why I put F. Eh? On the top part is porcine gelatin. On the bottom part is bovine gelatin. But you can look, it's already in their grouping. Even though we don't tell the system we have these three samples gelatin. This is unsupervised. We don't tell the system. It's not like discriminant analysis. But why it is good? Yang ni I cakap lah, Dr. Azilawati ni, this is very good. That it's not that analyst, food technology. So they run a few times, higher number of ni, and then they able to differentiate properly. Even the PCA able to discriminate them, even though PCA not meant to do that. Okay. So the grouping of the gelatin, it is due on the characteristic or similar characteristic of that particular grouping. Okay. And then the nearer the grouping of sample indicate they have similar characteristics as well. That's why fish is located on the right side. Porcine and bovine having a near correlation. That's why they are located together. The first one is the porcine and bovine are mammalian. Fish is not mammalian, definitely. Another one, there is also an indication some amino acid in porcine and bovine are having similar profiling. But with a good analysis technique, you is still able to differentiate the grouping lah, in this case. Okay. So this is how we explain the observation plot. So if you have your sample is near to each other, that indicate they have a similar characteristic profile. Sebab tu babi dengan lembu ni boleh duduk sebelah-sebelah. Have you saw babi and lembu stay together? We never saw babi stay in aquarium lah. Okay, so this is an example lah. Okay, another plot is we call it a biplot, where we superimpose the variable plot onto the observation plot. That's why you can see the variable plot here falls onto the observation plot on the grouping. Yang ni lagi penting. Why? We can pinpoint which amino acid actually characterize the grouping. So methionine, serine, histidine are characterizing the fish gelatin. They are dominant in this fish gelatin, but the fish gelatin have a low hydroxyproline. Why? Because they are negatively or proportionally vector. They are high with this amino acid, but low hydroxyproline for fish. Nampak? Faham For porcine, they are high in this VAR. Tak ingat apa nama dia. So there are 3 or 4 amino acids are dominant in porcine. So if we analyze the amino acid, we saw they are high content and particular amino acid, we can propose that might be the gelatin that we analyzing are from the porcine. Okay. For bovine, they don't have really dominant variables, amino acid, but they have low glycine and arginine because This arginine and glycine are in the opposite direction of this bovine group. So if your gelatin have a low glycine and arginine, that indicate they are might be belong to bovine gelatin. So this is how we explain lah. Okay, 348. Tak buat lagi ni, hands on. Okay, so any button to open this one? Kejap lagi, kejap lagi. Kejap lagi, kejap lagi. Belum sampai lagi. Nak balik sekejap So just a halal study case. Previously, we know that in halal realm, have you who like to eat catfish? Siapa suka makan ikan haruan, those fish? Okay, I don't eat that kind of fish because I'm allergic. It's not because of some issues, but there's issue. Those catfish that been bred in Perak, okay, they are being fed with najis and pork. A boiled animal pork. Yeah, actually. Okay, so this animal which been fed with najis and pork is considered a al-jalalah animal. So this is IUM, so we talk Arabic a little bit. Okay, so al-jalalah animal. So this is a paper stated by Dr. I think Dr. Beta and Dr. Aizat. They are in IUM, in Had. So because they are in Sharia background, so previously our fatwa say those al-jalalah animal can be eaten, can be consumed if we quarantine them. We take them from that pond, quarantine them at the clean place, feed them with the halal and feed, and then after I think 3 days, they can be consumed. So this is how the fatwa say. Okay. Why? They say there is some study say after 3 days when they conduct, no, the quarantine is based on the ulama preference. I don't know how they decide lah. And then there is some, I think lembaga ikan, something like that. They conduct a study on DNA part. They found after 3 days there is no pork in the intestine of the fish lah, ajalala animal. Okay, but what we did with UPM at that particular time, we say, did they check the fat profiles? So that's why this study coming in. Okay, so even though the fatwa coming because of the DNA approach, but we found this one, we carry out the triacylglycerol test on the glycerol part and some thermal analysis using the DSC, the one that we have in HUD. So we're able to differentiate actually if we have a mixture of lard and palm oil in the fish feed itself, the profile of lard still there after 3 days. So because of that, the fatwa now have been changed. So it would not enough with quarantine. So perhaps if the ajalala animal should not be consumed by us lah. As if we allow for them to quarantine, as if we allow the irresponsible personnel to just fed them with the najis lah, and then just quarantine and then we can eat. No. So we found that even though the DNA, no, we don't find any DNA, but after even a month, we still found there is a profile of lard using the fats and oil analysis. Okay. I see. Even from the fish punya isi and even intestine lah. So how to do it? Just do it the same approach. Analyze the fish without lard, fish only, and then put as the discriminant analysis that we did in the previous one. Okay. Okay. Itu tak pasti. That one not yet been that one is not yet being decided lah. Sebab I think plant is not considered al-jalalah. Dia al-jalalah is for animal. Okay, now we move to the last part, principal component analysis, PCA. Okay, now open back your data. Okay, click the number 2, simulated data principal component analysis. Okay. Okay, so this is your PCA. Okay, before we move that, for PCA, we only need training data set. There is no such thing as validation, testing data set. No. Because this is unsupervised, we just want to know what we have in our data lah. Okay. And then if you look at this table, there is a small table there on the right side, which is this table is coming from your DA. Your DA, open your DA again. Remember that this one, we have the significant variables. Mana ya? Ada this one. So I just choose these 10 variables. I bring to the PCA data, and then I only choose this significant one for our PCA. Just want to show that how we want to make linkages between DA and PCA lah. Usually, if you want to involve multivariate in your study, you cannot just use DA and then stop. You can even link DA, PCA, cluster analysis, heat map, so on and so forth by having these linkages. Yeah. So to do the PCA, go to Excel stat. Okay, and then click analyzing data. Click principal component analysis. Okay, and then on the observation and variable table, click that part. Go to C150, drag to C18, 3 and 6, and then drag down to the last sample. Okay, and then for the data format, you have to click observation and variable tables. Okay, for PCA type, there are 3, but we only choose correlation Pearson. Because we want to look the correlation between the samples lah. Okay, and for this one, how to produce our result, we just choose sheet. Please tick the variable levels plot box and observation levels box. And for the observation level, you have to click at that part and then choose the sample name. Starting with the sample title, drag down to the bottom. Is it okay? Before we move, anybody having problem? No? Okay. And then for options, okay, for the rest box, let it be. But for standardization, you have to choose n-1. Okay, why we choose n-1? Because we don't have too many data. So this is a representative of a population. That's why we use n-1. If our data is too many, a very big data, we can use n lah. Yeah? N for population, n-1 for samples. So this is the sample. Okay. So, supplementary data and supplementary observation and variables, just let it be. Yeah. Click nothing. Okay. Don't click anything. Okay. If I say click nothing, somebody will be thinking clicking it. Okay. Missing data, just choose do not accept missing data. Okay. For the group, just let it be. For output, click all boxes, but you have to make sure significance level is 99%. Is it the same? Ah, 99. Okay. Kalau yang tu 95 your default one 95 5 je. Oh, kalau macam tu kena tukar lah. 1. Okay. And then for chart, go to variables label, click correlation charts and vectors. Sekejap. For this one, it is state significance level or what? Betul okay. Takut salah. Correlation chart and vectors, just tick both of these boxes. For observations, tick observation charts, labels and colored labels. Okay. For biplot, click biplot. Option for variable, vectors and label you have to tick as well. Options for observation tick as well. But for type of biplot, you have to make sure you choose correlation biplot. They have different distance lah, symmetric. You just need to choose correlation. Okay? Is it okay? Boleh? And for your bootstrap chart, just let it be. And then click OK. So you will have another window here. So the observation and variable table, numbers of rows is 45. Column is 11 because we have 11 variables. Yeah? And then 11 fatty acid. Observation level we have 45 because 45 sample and one sample column lah. And then if it's okay, click continue. Okay, so it will appear again similar like your DA, but this time only 92.58%. Yeah, because this is not a discriminant analysis, we don't push the system. This is LUT. This is not LUT. So that's why they a little bit loosen up their system. We don't push them. Okay, so it become the higher the percentage is better lah. This time again, remember we have 11 variables. The result shall be displayed in 11 dimension. But as we told here, PCA is good for reducing dimension. So that's why the system only choose 2 dimension, F1 versus F2, or axis 1 versus axis Y only. So only 2 dimension will be plot lah. Okay? And then click select and then click done. Okay, sekejap ya. Let me zoom first. Okay, sama je sebenarnya. Okay. So you can see the result is in PCA and PCA1. Okay, you can look at any of the result. Actually, still the same. So the results is like this. The first part is on summary of statistics. Yeah, they will say similar thing. How many samples you have? How many minimum value, mean value, so on and so forth. This is not much important because this is not a raw data. It's a transformed data. How do you know your data is transformed? If you see standard deviation can become 1, mean can become 0, so that indicate these data are normally distributed. But you can see that C15 and C16, C18, the data are not normally distributed even though we have transformed the data. So that indicate it would not be perfect. If you transform your data at the first place, not all variable will follow normal distribution. They just able to reach normal distribution. And fortunately, out of them, some of them are really able to follow normal distribution. The rest, no. But since you have carried out normal transformation, that's enough. Because some people will be asking, even reviewer of papers, they still asking, hey, your one is not follow normal distribution after transformation, so should not be accepted. No, it can be accepted, but we have to take note. Not all data will follow normal or will achieve normal distribution when we transform at the first place. It still can achieve normal distribution, but not perfect. It will move towards normal distribution. Yeah? So usually I will answer back to the reviewer. Okay. All right. This one is similar like in the DA, we have the correlation matrix. Sama macam tadi. The 0.7, moderate, weak, so on and so forth. We have negative value indicate they are inversely proportional. Okay. This one not important. Okay. Remember this morning we talked about do we have enough data for multivariate data analysis for chemometrics? we need to use Kaiser-Meyer-Olkin test. So this is the Kaiser-Meyer-Olkin test 0.8018, which is enough for our study. So if I'm looking for a multivariate data, I will asking the researcher provide me this value as an evidence. If you have less than 0.5, that indicate your data is not enough. You need to do more replication, do more samples, and then go again for PCA. Okay. Fortunately, in the PCA, the KMO test has been embedded, so you don't have to find other KMO tests lah. When you want to go for KMO, just click PCA. It will indirectly or simultaneously calculate the KMO for you. Okay. Then we have here principal component analysis. Okay. This is the 11 dimension that I've said. Yeah, we have 11 fatty acid. So we have 13 dimension, but only 2 dimension will be plotted. But it's very good. Why? You can see here on cumulative information. This one. Cumulative percentage. Okay. Within axis versus y-axis, 2 dimension, the data, 92% of the data are really used in this study. That's enough. It's quite good. Yeah? The nearer is it to 100% is good lah. But in your data, in our study, since we know the plotting will be x versus y, so only 2 factors or principal component will be used. 92% are being used, meaning that they are meaningful in our study. Yeah. So the question is, how come we can get this 92%? Because from the DA, we get the 13 variables, 11 are the significant one, and all those 11 are being forwarded to use for PCE. That's why it can achieve a high accumulation percentage variability lah. Yeah. If you use 13 variable as well, the same with the DA, the percentage of accumulation will be reduced. Not all will be meaningful because DA already proved to us, yeah, the discriminant. Okay, this one is not an important one. Okay, this is another important part. We call it factor loading results. Yeah? This is similar interpretation. Any factor loading more than 0.75 is considered strong factor loading. No, sorry, strong variable. Factor loading between 0.3 sorry, bukan macam tu. 0.3 and 0. I think 0.75 lah. Okay. Is moderate variable. And the last one, factor loading which is less than 0.3 is considered weak variables. Okay, so this is the indicator. Okay, so out of this, you can see how about we bold the factor loading, the variable with factor loading, the strong factor loading, which is more than 0.75. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one, 1. Okay, so in this study as well, beside of 11, 10 are the most significant one that being streamed down by the PCA. In the DA, we talk about 13 variables. So out of 13, 11 able to discriminate or differentiate between sources. But when we bring this 11 to PCA, out of 11, actually the most significant one, only 10 Okay. Similar like I told previously, if it is negative, it is negatively correlated lah. If it is positive, it is positively correlated. Okay. But it is good to use the diagram, the variable plot for positive or negative correlation lah. Okay. So this one is the explanation that we can go. Okay. Again, to ulang balik. So C18-1, C20 and C18-2, they are positively correlated to each other. C17-0, C17-1, C18-0, so on and so forth. They are positively correlated. This one, ini sini tiga ni. These two are positively correlated. These two are positively correlated. Okay, but this one are nearer to each other lah. However, this one over this C18, they have no correlation at all because they have 90 degree. Even this one as well, almost. Almost no correlation. So this is additional information that everybody shall know lah. Okay. Let's go on the biplot. Sorry, not yet. A variable plot. So what you can see here, all porcine samples are located on this side. All lard only sample will located at this site. Those mixture of lard and palm oil located in the middle. Okay, it's like similar like our DA, but this time this is not very, what you call that one, a good display lah, because we don't teach the system, we don't tell the system what we want to look at. This is unsupervised, but the pattern is still the same. Then we can go to the biplot. So you can see all porcine samples containing high C18, high C20 and high C18 2NT, but they are low with all these variables. Why? They are negatively and they are in the opposite direction. So if you found this compound in your sample, high concentration, that indicate there is a lard containing samples lah. Okay. But in the middle one, only C18, 2 and C are the dominant fatty acid metal ester. So that is how we explain lah. Okay. So this is the biplot. So I think that's all about the DA. The rest is for calculation by the system only. Sorry, DA lah. PCA, Principal Component Analysis. Okay. So, okay. Boleh? So I think that's all from me. Nanti dulu. Belum. PowerPoint ada lagi. So this is just a cerita lah. Okay. So if you want to go for references, these are papers that I have assisted others and as well as I wrote on my own. But the data most of time are from others. Sometimes there are researchers, they don't know how to do the data analysis. So we collaborate together and then I wrote for them, or sometimes I request them to write first. I will make some amendment on their writing lah, make sure they have a correct interpretation. Jaga nama baik ya. Jangan orang publish, you put your name, you don't look at what they have been written for you, and then people will be accusing you putting a wrong information. So this is references. If you want to have them, please inform us. I will share as well. But some of them, they are memang we call that one open access, so you can simply download lah. Okay. So I think thank you. That's all from me.